Hey everybody. Uh, June 12th today. Happy summer. So for today's Propeller Live Forum, let's first talk about what we know we're going to talk about, and then we'll take inventory and see what other people want to talk about so everybody can make use of their time and decide what they want to do. So known topics today, Stephen Morocco will be sharing an update to the Spin 1, Spin 2, FlexSpin um, extensions in Visual Studio Code. Primarily showing it with FlexSpin today. So that's a known presentation informally. Is there anything else that people will be sharing of significance like that? Okay. Anything not so significant, support questions or just topics people have in their mind that they'd like to ask Chip about or projects they'd like to share, anything like that?
I could briefly mention some of the changes I've made to the RISC emulation for MicroPython, and I have Rust working, well, starting to work.
Perfect. All right. Anything else?
3.3%. That is the rate of inflation in May from a year ago.
No, no, we don't want to hear about that. Okay. All right. So Eric, anything else there? We could bring up topics when we're ready to. So that sounds fine. Okay. Before Stephen gets going, I realize we've been a little bit quiet at Parallax lately. I'll show you what I've been working on, which you've seen before. See again. So this looks like our Cyberbot product until you realize the scale of it. And this robot goes with RNI to our events in the summer for education. And it's a full-size 5x scaled model of the Cyberbot. And it has a Propeller 1 in it too. So here it is rolling around our office after I rebuilt it from a recent fire. That's right, a fire that happened in a Pelican case in the back of a UPS truck on the way back to Parallax from wherever this robot last was. I have the record in Parallax of starting the most fires. And no, I don't have any disorder about creating fires or interest in that, but it seems like whenever I work with big batteries, I get in trouble sooner or later. But the prior robot had no fuses on it, and I received a very disappointed look from Andy when he pulled me up to see it, and he hung his head low and then made me do the same. And we went over why it caught on fire, which I don't really remember. But it's working now again, Ari, so it's shipping to you for Florida. And this thing was so fun to build. I know I'm always talking about it, but I love the welding part of it. And if you look closely at that body, it looks just like the sheet metal folded version of the 5-inch, 4.5-inch chassis, but this is really 36 or 40 inches long, and it's really thick. So that's back. And the wheels here, these resemble the wheels that we have exactly scaled up. And there's a one of those window motors inside of it. But these are made at Chip Shop with Doug. I'll just show you that picture one more time so you can see it. Yeah, there we are. So these wheels were made on the CNC at Chip's office, and they're 12 inches in diameter. And we found a big O-ring. It's just like what we have on the little robot.
Oh no, probably sounds not worth the time.
And Doug made those. I showed up and he made them in one day and had them fitted. And then I was on my way. A lot of fun. Okay, Stephen. Do you want to go first or should we have Eric?
Oh, let's have Eric and then I'll come in behind. Because
Maybe some of what Eric has pertains to what you're doing.
Well, I'll come in behind with talking more about how we support his FlexSpin.
Eric, you want to tell us about FlexSpin updates?
Yeah, sure. I have recently released a new version of FlexSpin. It's mostly just bug fixes. for this version. I do have a new version under development that'll support Chip's structures. And actually, I wanted to ask Chip if those are going to change much, because I kind of got the impression they were.
Yes, they are going to. We'll have like on the fly assignments and things like that. But it's all been it's in a state of flux now. I've been working with Steven, and then this last month I was doing farming stuff. And so I haven't made any progress on that in like 2 months, but I intend to get that wrapped up before too long.
Okay. Do you have any notes about how it's going to change or what might be coming?
Not really. I have a file that I've been working with. It's kind of like my guideline file, but it makes sense to me. It probably makes sense to you too. It's just sort of a syntax list of possible syntaxes. But the big hang up was how to modify the pointer variable itself like a normal variable. I'd been talking a lot with Steven about that, but it seemed that there was no consensus on how that syntax ought to look. That's really the only thing that's, the rest is pretty anticipatable how it would work, but how to modify the straight pointer variable was like a unresolved yet.
Well, don't we have already, like there was a declaration syntax in the last spin release where it had like an up arrow for the pointer?
Yeah, how did that work? So that's for like using the pointer, but then if you want to modify the pointer variable itself, I had wanted to put it into square brackets, because that plain syntax isn't used anywhere else. But it was at least Steven and I weren't really on agreement that that was the way to do it. So Steven was just the only person I was talking to about it. But that's where, so it kind of just got hung up there, and I haven't made any progress on it since.
Okay. Well, maybe I should go ahead and release what I
Yeah,
have.
go ahead and I mean, what I'm going to do, it's going to more or less work like what the last version I posted is working, but it's going to be a lot richer than that.
Okay, so you'll be adding features but not subtracting.
Man, I can't remember exactly because I've been off it for like a month, but
okay.
It's not going to be anything big for sure because there's only so much you can do with periods and whatnot.
Right. Okay. Well, with FlexSpin, I basically did what I had suggested, that structures are objects. They're like mini objects. And
okay.
So they probably are a little bit richer than the original idea, but
yeah.
But it all seems to work. It's compatible with what you did. So
okay, well, thanks for making it so. I'm sorry I don't have mine resolved yet.
Oh no, that's fine. So I hope to have a release of that sort of soonish. I had to make a major change to the way I parsed things, so it's a little bit unstable still. So that's why I'm still maintaining there's a 6.9 branch that has just the bug fixes on it, and that's what I sent up to GitHub the other day. And there's going to be a 7.0 branch with the structures and other features. That's FlexSpin. Steven, I know you were having trouble with load P2 on the Mac. I actually just ran it a bunch of times and it is a little flaky for me. So there's some kind of timing issue.
Yeah, that's similar to what I'm seeing. I've had the reason why I'm not releasing the changes I'm going to show today is I want to make sure that it's nothing I'm doing and how I'm driving the tools. I'm seeing download problems with Load P2. I haven't taken time to run your other suggestions yet. With
Prop Loader seems to be a lot more stable, so maybe for now you want to use that instead of Load P2.
Yeah, it's a simple change for me, so I'll go ahead and check that, make sure it's working. There'll be some growth in the future about how we want to make this work, but I'll run tests on that today and get feedback to you today about what I'm seeing.
Cool, thank you.
You're welcome.
So the Load P2, I am kind of actively developing it because I've got this RISC-V emulator. And that's used for MicroPython. Ken was asking about that. So, and I've recently made a change to it so that it can run code from the Flash. So that will allow us to have a lot more data space for MicroPython. So you can download your program and keep some of it in the upper part of Flash and run from there directly. There's still, unfortunately, still a limitation that the total address space is only a megabyte. That's due to some internal design decisions I made earlier where I used the low construction and some other instructions that only have 20 bits of address. But it still opens up a lot of possibilities because it does let us have a lot more of the MicroPython libraries compiled into the executable. So Ray has mostly been doing that. I've just been trying to support him with the compiler changes. Something that would be really cool to have would be a way to access the Flash and the SD card at the same time. And we've kind of gone over that a few times, and everyone can sort of agrees that it's theoretically possible, but I don't think anyone's doing it in practice. So that's something maybe we can try to hash out together on the forums or something, because it would be really useful to have an object that could let you read raw data. I don't think we want to put a file system, like the file system would be built on top of it, but just to have like low level access to the data in the Flash and the data on the SD card.
Hey, Eric.
Yes.
The problem is that the SD card can become stateful and go into a mode where you can't also then disengage it to talk to the other Flash chip, right?
I'm not sure. I thought Evan had figured out a way around that, but I don't know where we are with that.
Shy of powering it up and down again.
Well, then maybe it won't be possible, and we'll have to rely on the Flash for storage.
Yeah, I don't know, but
yeah. Or the there's I think a board for that Parallax has for the SD, an expansion board, although that I see is discontinued. So, but maybe if there's enough interest, it'll be continued again.
yeah, Ken, what's the status on that?
I think there's an adapter that we have instead. Are you referring to the Propeller 2 demo board, Eric?
I was referring to, there's a micro SD adapter, I think, yeah, for the Edge and other boards.
Did it have a PFAT to cycle the power on the micro SD card?
I can't remember. I don't actually have one.
Chip, the Parallax version does not.
Yeah, okay.
I built my own board that is it's in kind of a standard P2 accessory format that does have a PFAT. In fact, I made one for you that will show up in the mail shortly.
Oh, thanks. Okay. Yeah, if we get it onto other pins, things simplify dramatically.
Yeah, that would be pretty good.
We do have the micro SD add-on board. It's an active product, 150 of them in stock.
Okay, I thought it had said discontinued on the website, but maybe I misread it or looked at the wrong thing.
No, it's very possible. There are a lot of things that get discontinued too.
Okay, if there's still 150 in stock though, that'll last a while. So good. Yeah, the way that Ray's been building MicroPython is he uses my RISC-V emulation, I guess people call it, although I like to call it a just-in-time compiler, which basically turns a RISC-V toolchain into a P2 toolchain by adding a small piece of code at the beginning of the generated code that translates the RISC-V instructions into P2 instructions on the fly.
Cool.
And that so I've extended that so now it can read the RISC-V instructions from hub RAM or from flash, which is why we can store it in flash.
And that gets around the 20-bit address limit for sure, right?
Well, no, the 20-bit address limit is built into the interpreter, unfortunately, the just-in-time compiler, because it translates the instructions and then caches them. And there's a table in LUTRAM for the cache, and I was trying to cram everything in there, so I just used 20 bits for the address.
How much does that MicroPython want for memory to be comfortably usable?
I mean, it's usable in the 512K original, but you don't, you have to pick and choose which features you want to enable. And if we wanted to have things like, nice graphics and a fancy frame buffer or what have you.
Yeah, I definitely need more.
We would need more RAM. So this would give us the option to do that.
I see.
And yeah, I think I agree with Lachlan that the 20-bit limit we can live with for now, because it ran in 512K. So if we have another 512K now for code that's not used as much and we can put in flash, then that's cool. The other thing I was going to talk about a little bit was that this RISC-V translator works for any RISC-V toolchain, and I've adapted it to the Rust compiler. Rust is a newish language that's kind of all the rage now. And I've managed to get a blinking program, LED blinker in Rust running on the P2 now, using the RISC-V, the standard RISC-V toolchain with a small blinker script.
Hey, can you explain what Rust is and what it's like in a nutshell?
Yeah, Rust is a systems programming language. I think it was developed at Mozilla, and it's kind of like C++, but memory safe. The compiler analyzes all the memory accesses and won't let you use stuff that's free. It controls, there's something called a borrow checker that forces you to keep track of who owns memory at any given time. So it's billed anyway as having the advantages of a garbage collector, but without the cost. And it's also got all kinds of, there's a lot of standard libraries for it. I have to begin porting some of the low level, serial code to the P2 in order to use most of those. But it's really been popular. I've actually been having to learn it for my work. So this is a chance for me to combine both a little bit.
I see. Cool.
It's being used in the Linux kernel now for some device drivers. Again, the idea is that it's because it analyzes the memory accesses, you don't get the buffer overflows and null pointer. And
so it's good for safe programming.
Right. That's what the intention of it is.
Well, that's appealing.
Yeah. And it is supposed to be for embedded systems, although these days embedded it kind of means less than a gigabyte of RAM. So we'll see how well it works on a P2. But I know people have been running it on Arduinos and stuff, I think. So
less than a gigabyte of RAM. That reminds me of something that I saw recently. Apparently Spotify made some sort of device that's supposed to connect to a car radio, and then they discontinued it. And then everyone complained, oh, you should open source the software, and they actually had it somewhere on a bizarrely unnamed GitHub account. They actually did have the kernel source for that, but then everyone complained, oh, it's too underpowered. And underpowered here means a gigahertz processor and 512 megabytes of RAM. It's a glorified MP3 player. What do you want?
Yeah, well, these days.
Allegedly it works quite well. So why would it need more memory? Bizarre. Why does it have that much memory to begin with? That's excessive.
Yeah. Yeah, these, I mean, well, Moore's law has brought everything down and programmers have gotten lazy, I think. Because, the P2 512K of RAM is actually a lot. You know,
Yeah, the
you should be able to do.
512K, you can do a lot of that, and even like the 32 megabyte, that's like huge.
Yeah, yeah.
Like if you think about how much just stuff you can cram in there, it's like, why is everything that's on the PC so large? Like, what is it doing?
Yeah, definitely. So that's kind of what I've been up to mostly, the new Flex Prop release, and extending load P2 to let you download things to Flash, and using the Flash for the RISC-V and Rust tool chains. So,
Any questions for Eric or requests? I'll just continually encourage everybody to make a deposit at his Patreon account. So maybe somebody can go grab that link and drop it in here.
thanks, Ken.
Sure. I realize our Parallax contribution was broken for a long time when my credit card got compromised. So I'm going to restart that. Okay. Sorry.
Oh, thank you. That's great.
It's embarrassing. Okay. Before we go to Stephen, then Johnny Mac, since you use Microsoft's tools, you pointed out something here. Maybe you could share it.
Yeah, it's been in the forums, but I think a lot of people, because Marco is I don't know if he's shy, but he doesn't participate in these meetings because it's very late in Italy right now, and he doesn't push very much. But his IDE called Spin Tools is really quite nice. It looks very much like Propeller Tool, except that it has a side panel that shows you an outline of your project. In fact, I got a very funny email from Michael Mulholland a couple of weekends ago, and it was as if he discovered, you know, some long lost city filled with gold, and he had discovered Spin Tools. He didn't know that it existed. Somewhere he came across it, and he said, "Oh my God, this is what I should have been using all along." Well, what Marco has done, I and other people had requested, now he's done it, is given, oh, well, let me back up for a second. Marco has his own spin interpreter and compiler that runs full time. So it's like some other tools where as you're typing code, it will tell you if there's a problem. And so it does that in real time. What I, though, wanted to have was the ability to use Peanut or another compiler, you know, FlexSpin, for example, and now you can. So Marco has added the ability to compile, to do your final compile with Peanut or FlexSpin or any other, I suppose, compatible compiler. And I'm using that now. The nice thing is, for those of us on Windows, is now I have an environment that looks very much and feels quite a lot like a nicer version of Propeller Tool. And I have access to all of Chip's, you know, fancy schmancy debug screens that only run in Windows. Prior to this update, Marco could do the basic text debug that, you know, we get the basic debug window. He could do that. But now we can do anything again in Windows, and so it's quite nice. And since it works across platforms, people that are using FlexSpin on Linux or on Mac could now use Spin Tools and have a very nice compiler or editor environment.
Besonders meine Mann.
Sorry.
Just I muted. You can carry
Anyway, it's a small feature add, but it was a big impact for me because I still was wanting to, for any of my production work, I wanted to use the Parallax, you know, canonical compiler, and now I can. So as Chip makes updates, now I can access them. The only issue that we're having right now is that Marco's compiler, for example, there was a discussion earlier about structures. And so Marco and Eric are going through the same thing. That, you know, Chip hasn't finalized all of that. So I was working on a program the other day using structures, and Marco, the Spin Tools, was flagging all kinds of problems, but I could compile it. The nice thing is that the problems he flags are only from the internal compiler. If you call an external compiler, it will work. And so I was able to compile programs with structures, spin2 structures, with the latest version of Peanut.
Cool.
Yeah, well, thanks for sharing on his behalf, John.
He's done, like Eric, this is hard work, and both of them, have built stuff for the community that we need, and so I'm glad that and especially the people that were on Mac and Linux systems that are using FlexSpin. Now it's just another environment. And it is quite nice. I like it, especially with the outline. That was what really got Michael going. He said, "Oh my God, that outline is fantastic." So, we could fold code in Propeller tool and look for something, but now you don't have to. So you can use your favorite compiler with that very nice environment.
Right on. Well, any questions for John since he's familiar with that tool? Thanks, John.
I'd just like to say it's really great that Mac has done this and that we do have so many choices. Like it's good to have options and lots of tools.
Yeah, humans will do human things, and we all have our comfort zones. Do you want me to? I have that open. Do you want me to just show it really quickly to see how easy it is to use?
Yeah.
I haven't shared my screen in a long time, so I have to. Oh, there it is.
It's still the green button.
Yep. All right. So, can you see the?
Looks good.
Okay. And so you can see I've already run the thing down here, but to access it, you go into preferences and tools, and then you set them up. So for example, I have a Peanut RAM. This is the equivalent of F10, and then Peanut Debug, which is the equivalent of whatever, Control F10. And we'll look at it. So it's pretty simple. With you set it up, you point to your compiler executable. Now, since Peanut doesn't have a library path in it, I just keep a copy of Peanut in my library folder. That seems to work. And then the command line, that you would use. I'm sure Steven's got a lot of experience with this since he's been calling Peanut from the command line. But that's all there is. And so if I go here and turn on the, this is what I was talking about, Chip. I still want that. So if I do this, and then these use those tools come under the Alt buttons. So if I press Alt 2, that will do the it will do the program with debugging. And so here you can see that it pulled up the debug, the main debug. I'd enable debug main in the standard debug window. So in Windows, you get everything that Chip has in Peanut, along with, again, the environment. This is what I was talking about that Michael likes so much, the outline view that shows you everything that's going on in your program very quickly. So there it is.
Thanks, John.
Mm-hmm. How do I stop share?
And what John really wants is a micro driver. Hey, John, why do you use the Maca tool over Propeller tool?
Well, because, you guys said you're not developing Propeller tool anymore, and Chip is always actively developing Peanut. And so always before, there was a very long delay because of all the work Jeff had to do, especially the testing cycle. Jeff is very, very rigorous with testing. So it took a long time to get features from Peanut into Propeller tool.
Yeah.
And so now that's no longer an issue. When Chip has a new version of Peanut, I just put it in there and point to it, and away we go. There are some niceties still. Propeller tool, I still use it to edit. Sometimes that whole alt select of blocks of things and moving around, I really like, and we don't really have that as nicely in spin tools, but you know, it does, it's close, and you know, especially with the outline view, it's easier to find things. It does code hinting. So, you know, when you type in say an object name, and then when you press dot, it will then show you all of the methods and constants for that object. So it's really very nice. You know, it knows, it has built-in help for everything for spin 1 and spin 2. So again, Marco is done, and this is not, sorry, I don't mean this to sound like a knock, but spin tools is what Propeller tool, what I hoped it would ultimately become, but you know, resources didn't allow that. Now we have it. And it's cross-platform. That's a really big thing that's important for, you know, Chip and I are Windows users, but aren't you a Mac user, Ken? And, you know, a lot of people are. Now, you know, now they have a tool that looks and works like Propeller tool, where we have a tool, and it will work on any OS.
Yeah, and Propeller tools will be continually maintained to work as long as we can, but new features are not likely.
Right. Well, the current, even the last several revisions of Peanut are not embedded in Propeller tool. So the compiler is quite inside Propeller tool is long out of date.
That's correct. Yeah. Yeah, the reason for that is our IT guy retired last year, and so it's taken a year of Jeff's time to get an understanding over all of our systems. Because Jeff did IT back in the late 90s when he first joined Parallax. But yep.
But anyway, again, thank you to Eric and to Marco for what they're doing, because they're giving us, you know, as critical as I am sometimes of lack of library support, the Propeller 1 and Propeller tool are the coolest pieces of silicon we have available to us.
Mm-hmm.
I say this strongly, having had to use some other products recently.
Thanks for that, John. Okay, Stephen.
All right. Thank you, John. That was fun. Let's see what this shows. All right. So we've been working on, in similar lines that Maca just added. I've been working with Visual Studio Extension, rewriting the support, of course, to language server and things like this. It's given me a lot of understanding of how things work behind the scenes. And I'm feeling a lot more comfortable now in being able to develop and extend in directions that we need. In previous, we've had the ability to run FlexSpin and behind the scenes, but it was very unwieldy to manage the compilers. And so to switch over to Peanut or to switch over to FlexSpin, it was a mess. You had to modify an external file and things like this. And so there were also setting debug flags and things like this that were all problematic. So with my latest understanding, I was able to go back in and do very similar things. And so now we have, here is some Spin 2 code, and I can compile it with, and you see at the bottom, here's some Spin code, and I can compile it, and it's kind of automatic, switching compiler directives and everything else. And we have the ability to download that. But what's interesting is no matter what you're looking at here code-wise, you now see that you can toggle the debug settings. You can toggle the debug setting on and off for compiling the debug statements. You can also toggle your download to flash or RAM. And this is the particular prop plug that's recognized. And if you have multiples, you can just click here to choose which one you're going to talk to. That fundamentally is what I've been working on. So FlexSpin for P1, FlexSpin for P2 is automatically handled. Same thing with the downloader. It automatically chooses the right downloader. In order to make this happen, I've added toolchain discovery to the VS Code extension. And so now we have new sections in here: toolchain discovery and prop plug discovery. And this, of course, is working on all platforms. So we have now, we can choose configuration and it'll list the compilers you have installed. And so, as we were just mentioning, when you're on Windows, you have Peanut and FlexSpin, and we have FlexSpin on the other platforms. Peanut only does Spin 2, and so if you were to select Peanut and try and compile Spin, it'll just tell you you can't. And FlexSpin supports both, and so it'll just automatically handle compilation and download for both. You choose your compiler by taking whatever name you have in this column and typing it in here, and that is machine-wide if you save it in user settings, or it's for an individual workspace if you save it in the workspace settings over here. So you can have different projects that use different compilers, and it'll be remembered as you switch. This is the debug setting, which you saw is on the control line, so you won't be playing with that. But you can control listing output. If you want to control how debug statements are compiled in FlexSpin, you set up the control option right here, so G break or G for printf. Enable flash, this is done through the interactive. Enter terminal after. You can choose how you want to be able to do that. This is your communication with debug, the rate at which your application is going to be communicating over serial. And so defaults to 15.2 as load P2 does, but you can set that all the way up to 2 megabit. And then it describes where the tools were when they were found. And then your prop plugs that are found on your system. So if you're on Windows, this says COM over here and the serial number. And if you're on Raspberry Pi, it tells you the USB 0 or USB in that you have attached and the serial number and things like this. This is automatically discovered. I can't control whether these buttons show, but you won't be using that. They're automatically discovered. And then this is the one you have currently selected. And so this is all now built into the Spin 2 extension. Switching compilers is very easy. Why did I go down this path? Because we've been lacking in FlexSpin support and the easy switching between compilers. And now you have the switching to compiler right here. So I think that's pretty much it. Anybody have any questions over that?
So you can switch the compiler, but what if you wanted to change some other setting? Like, so in FlexSpin has a lot of settings. You can change the backend, you can change the optimization levels, you can change the character set. Where do you set those?
Yeah, that makes good sense. This is, I have to reiterate that this is, certainly if that's something the community wants, I can add that in quite easily. My original intent was to make it for the beginner, like the beginner using Propeller tool. You're coming up, you've got your hardware, you want to compile your first code and get it downloaded. And so I'm trying to get the Spin 2 and Spin 1 environment to work really well and really cleanly for those users. If you're doing things like loading different files into different regions of memory, I probably won't go there because you're going to use an external build system to make that happen.
Yeah, that makes sense. But it's like, you want to be able to set like the bytecode mode. That's pretty essential.
Okay, then I look forward to your giving me a list of things you want to set, and I'll make
just type FlexSpin into the terminal. It will list you all the options that exist.
Yeah, but not all of them are.
Which ones? Right, yeah. Exactly. I won't know which ones are important for you.
Well, and just look at them and see which ones seem important, right?
I don't know because I don't use it that frequently. So I'd look for your advice to tell me which ones you think are important, that you'd set by project.
Well, you know how you have to pass -2 to get it into P2 mode?
Well, I know how to pass options, yes.
Yeah, but P2 mode is -2, right?
Yes.
So -1 is P1 mode, but there's also -1 BC, which sets bytecode mode for P1.
Okay, so
that's a
combination. Yeah, I need to know combinations that are useful because I'm not an experienced user with it.
Well, that one's quite important because if you use assembly mode in on the P1, the RAM fills up very quickly.
Right. So if you would help me with that, I'd be glad to add whatever you need to
Yeah,
make
it's
it useful.
just the flags basically. You can kind of almost treat it like a separate compiler because to a large extent it is. So I would just auto discover that as a different thing entirely. I don't know. That seems like the lowest effort version.
Maybe there could be a way to run like for the compiler, you could enter a script file or something. If it started with the word FlexSpin, like FlexSpin 1bc dot sh
Yeah,
or something.
we could very easily do things like that. So I look forward to being guided by what you feel is useful. I put the basic support in so it's automatic and just works. There is, I think adding things are pretty simple. I can turn around changes like that literally overnight. So I look for guidance.
Also, the other day I found a feature that was missing. I mean, this could wait until later, but I could show it to you. It's very simple. Which
Yeah,
is in FlexSpin, you can use in assembly, you can access a local label from outside of its context by sort of using a colon after the parent label.
There's a baby fawn.
Okay.
Okay.
Let's see if we can demonstrate such an oddity. Where is it?
We have a lot of work, Ada. We have a lot of work to add.
Yeah, it looks like this.
To add support for FlexSpin semantic changes. And so I'm not there yet with it, but we'll get there.
Anyways, I sort of just realized that there was even a feature, but quite recently. I think
It's
I've
kind of abusing it, to be honest, Ada. You know, a local label is supposed to be local, so.
Yeah, but sometimes you just in this particular case it makes sense because I'm trying to patch some instruction somewhere, and if it was global, it would make a giant headache. This looks like this. I have to patch this instruction, and it would be annoying if it would have to be global. And a lot of time I did make things like that global, and it was annoying because then if it's inside a loop, you also have to make the loop top global, because the bottom of the loop has to jump back up, and then everything becomes global. Very annoying. So then I realized that this was a feature. I think I've saw it in documentation at some point, but it came to me in a dream. And yeah. And of course, the extension hallucinates its own error over top of that because it does not understand what colon means. What actually happens if I go to definition on this? Nothing.
Thanks,
I
Ada.
can go to
And
definition on it.
like Steven said 2 or 3 times, if we can provide him with a list of these requests, he can act on them.
Yeah, I forgot. I mean, I've been terribly disposed. So I didn't even have time to report that bug.
Any other questions on the new spin extensions? I expect to have this compiler support released in the next week or so after I make sure that the issues I'm seeing have nothing to do with the release. It's ready to go otherwise.
It looks really, really cool, Steven. It's so nice to have Visual Studio. I mean, it's such a powerful environment, and to be able to pick different compilers is really nice. So thank you for doing that. I did find you had mentioned load P2 on the Mac wasn't working. The FIFO was too small, the default FIFO size. So I've increased that and uploaded a new a new version. So hopefully that'll be a little more stable. It worked. Of course, it worked the first time I tried it, and the first few times I tried it, and then it started flaking out, and I was able to figure it out.
Good, good, good. Well, I'll be.
I had
Yes.
a quick question.
Mhm.
So you're running this on the Mac environment with VS Code. I'm assuming this will all going to work the same way in Windows environment.
It'll work in the Windows environment, and you also pick up Peanut as an opportunity to compile. And it'll work on Raspberry Pis as well, or any Linux system.
Okay, sounds good.
So it's all working well. I have actually tested compilation and download on all platforms, and that's working. Except for the issues that Eric and I are currently bantering about right now. But other than that, I actually tested, and it's working on all platforms. It was also, I guess I'll stop there.
That was the only question I had. Thanks, Stephen.
Oh, and Grover, by the way,
Yeah,
thank you so much for your help on testing. I still owe you a lot of P1 semantic fixes based on your testing.
okay.
That's coming as soon as I get around to working on that again.
Well, I would be testing on P2 if you want, but I don't even have a P2 device at the moment. I still have my P1, but still, I'm happy to test to help you out. And it's no problem.
I appreciate the offer. Thank you.
Yeah.
Rover, I can send you a P2 if you send me an email.
Okay.
Imagine that.
I can do that.
Okay, deal. You help
All right.
Stephen. And Stephen and Chip, since you guys are also working on the TypeScript compiler and we had a little bit of break on that, there might be people here who don't know why we're doing the TypeScript compiler and what it does. And maybe one of you could just summarize briefly where you are with that effort.
I can do that very quickly. We have everything but the debug statements compiling at this point, and my testing has been on all platforms running the Peanut TS compiler. And so, John, you mentioned canonical Peanut. It's going to be the same thing with the TypeScript, but it's going to be on all platforms. And so that's what we're doing. I expect, fingers crossed, we're getting close enough. We have to do coverage analysis and verify our error reporting after we get the debug stuff in. So we have those three things to work on. I'm expecting, fingers crossed, that we might be able to make a release by this July live forum. So we'll see. We're getting close.
And the goal of that is web-based compilation. So ultimately no local installation of any tools will become an option, right?
Yes and no. Yes, that is one of the goals. Alternatively, it is installed locally as one of the compilers that runs on all platforms. And so like FlexSpin, you can run Peanut TS, and both compilers will work on this backend beautifully.
And I think that's important
and
too.
The same thing, and I'm coordinating with Marco right now to see if he'll be ready to allow that as an external compile as well in SpinTools.
Perfect. And if you put it in that kind of environment, then we can ensure that code is compatible across different platforms. So if somebody goes to the TypeScript compiler, it'll work already.
Correct. One of the things we do in Vision is we should be able to imagine that we could also make this run behind the OBEX server. And so now we can think about nightly builds and which objects are breaking with the released compiler and things like this. Flex may already run there, and so we can probably do longer term. We can think about nightly builds of Spin2 code and Spin1 code and providing results with objects uploaded. So longer term, that's something we could be able to think about.
And the compiler compiled into JavaScript is actually not that big, right?
Correct. It's actually quite small. And so
like how small?
I don't remember offhand. I've been so busy.
Wasn't it like,
it's small enough that it's a very tiny install.
Last we spoke, wasn't it like 1/4 megabyte or something?
That sounds about right. Maybe a little bit larger.
Oh, that's really cool. So it could, in theory, fit in the flash of a P2 and get served by a web server running on the P2 or something like that.
No, I wouldn't. No. The compiler versus the runtime environment are two different things. However, the runtime environment could probably fit on the Wi-Fi module. You see what I'm saying on the ESP?
Yeah, we don't write the runtime environment. That's
Right.
something that exists for
It
various
requires a Node.js runtime environment.
No, he was
No,
talking
no.
about like serving the JavaScript into a web browser that's connecting.
Yeah, that's what I meant. But you'd be on the PC and compile on the PC, but you'd receive the JavaScript from your P2.
I don't
Wonder what's
envision
the
this the way
smallest JavaScript interpreter is, because the usual V8 one is mega bloatware. Surely someone must have figured
I
out the
think
smaller one.
Samsung has one, I think.
Anyway, the net result is we'll leave that to the community to solve some of those. We're trying to get initial release out.
Oh yeah, definitely.
Steven,
Lots of opportunity or things we can do with the compiler once it's platform independent like this.
Yeah.
Steven, I have a question.
Please.
So there's a lot of logging statements in that code, right? So that we can debug it as we work on it. But did you make, I know you're probably thinking not to do this, but did you ever make a filter to completely, like for the final executable that people would use, where they're never going to see a logging statement? Did you ever make it so that it actually just strips those from the file rather than just calls something that doesn't do anything?
I have not at this point.
Because I wonder.
I'm also seeing as we get onto the smaller platforms, such as an ESP, maybe we'll care about that. But on the machines I'm working on,
Oh, I know it's
from really slow Windows to anything else, I'm seeing zero performance. That you would not recognize a performance degradation because it's that fast.
Yeah.
And so making it just a tiny fraction, split seconds faster, doesn't seem like a useful thing to be doing at this point in time. It's a feasible thing we could do longer term. So if we find a need, we can add a filter to make that for the distributions, but I wouldn't go there until we found an absolute need for it. I mean, I'm the one that, I've fielded rewritable optical disk drive operating systems with debug in. It's not worth the risk to be gutting code just for a tiny bit of performance.
I know. I'm just interested in the esoteric matter of how small could it be.
I'm interested in
measuring the compiler versus measuring the runtime environment. The compiler size is lost in the runtime environment right now.
Oh, I know. Yeah, it's like a drop in a bucket.
Yeah, and so what I do to the compiler is also lost in the runtime environment. So, if we find a reason to go there, I'll go there, absolutely. I'm not against it, but I'm not going to spend time on it until we know it's necessary. Optimizing my time too, right?
I like that.
So, yeah. Chip, you're fun. I know you're always thinking about these things. So I try to give you answers where I can that are
well, I can't help it. I might have a problem.
Doesn't bother me.
That's always the thing. Maybe everyone else has a problem, right? If they all say you have a problem, but maybe everyone else has the problem. It's all very dependent on point of view.
Always.
Be true to yourself. Unless you're trying to ship a product for Parallax, you could finish it first.
Okay, any other questions? And thank you.
Just a sort of general question on the TypeScript compiler, or general comment on TypeScript compiler and compilers in general.
Sure.
And I've just noticed while I was working on the load P2 stubs, I'm a terrible assembly language programmer. I keep making typos everywhere. And so I've got a bunch of warnings in FlexSpin for things like forgetting to put a number sign in front of a constant that might be kind of useful to add in Peanut and Peanut TS.
Oh yeah, that's a massive feature.
Yeah. So yeah, if anytime you see things like that, Eric, send me hints or drop me a line.
Sure. Yeah.
And
I'm trying to remember what the other warnings that one's the one that I caught. It caught several bugs.
yeah,
But I think there's also forgetting to put flags on a compare instruction, I think is the other one that I run into.
nice.
So if
Yeah,
if
compare
there's
that
no,
doesn't do anything.
yeah. So it's just a warning, if you really insist
Sure.
on doing it, the compiler will
Sure.
let you, but
Feel free, but why? Yeah.
yeah.
Thank you for
Why
this
is
really
that even an
fancy
allowed
law.
encoding of the instruction? That's a better question.
Yeah. So yeah, the net result is part of our reason for doing this is it's going to be much faster to add regression tests and to add new features to the compiler now that we've cut over to the new form. And we're going to be demonstrating that to ourselves as we go from 43 to the 44 that Chip is releasing in Peanut. And so proving it to ourselves and that. So you'll see us training ourselves in extending the compiler. And so if you have small things like that, it wouldn't be hard for us to add in that quick training pass. And so feel free to send me those kind of things right away, and I'll keep a note of everything you send. I also have an issues, it's not publicly available yet, but there will be an issues, so you can file feature requests and everything for the compiler once we release it.
So will there be like a Git repository somewhere that we can send pull requests to?
Absolutely.
Great, thank you.
You're welcome. Yep, right now it's a bit private because it rearranges a lot. Nobody wants to follow what we're doing right now.
Where would you put your % complete towards the first release of a beta?
I don't have a sense for how big the debug support is, so I can't say. Maybe Chip does.
You mean relative to what we've already done?
Yes.
I don't know. It'll add a couple %, maybe 4%.
Yeah, I've implemented the debug stuff in the FlexSpin, a large part of it anyways, and it's like tiny.
Good. Okay.
It's like Eric did some of the parsing, but it didn't work properly, I think, initially. So I had to fix that, I think, to make it work properly. And then the actual generating the debug bytecodes is very simple. It's just there's like one file with a bunch of functions in it, and it does that.
What was noon?
Very sweet.
Get out of the tube. Look at my phone. Get my phone.
Thanks, Stephen, for the excellent work and summary on that.
Oh, you're welcome.
But it's not part of Chip's self-hosting computer concept, right? It does not depend on TypeScript compiler.
It may not. I don't know. We'll see how this thing shapes up and what we can do with it.
Mm-hmm. I think there is a potential future where it can sit on the Wi-Fi module and you can interact with it that way with your web browser, and then download the code you compile there. So there is a potential there of some sort. We have other things to attend to first, but we'll get there. Maybe somebody with Wi-Fi with a Wi-Fi module experience could actually work on that path while we're working on other things. That would be useful.
I think PropLoader has the Wi-Fi download support already.
It does. It does.
Yeah.
And in fact, that's tweaked me because up to this point, I hadn't thought about supporting Wi-Fi downloads from the VS Code extension. But because you have that, I could probably hook that and provide the same thing that I do for USB attached prop plugs right now. So you're showing me I have more work to do potentially. Thank you.
Sorry.
No, it's a good thing for all of us.
Yeah, I think actually at one time I meant to cut over to PropLoader because of the Wi-Fi support. I didn't write the Wi-Fi support. I think it was I forget his name. He works for Parallax from Hungary.
Michael.
Michael?
Michael did the Wi-Fi support. Yeah. And I just incorporated it into the P2. Like I kind of extended prop loader a little bit, but it was all based on his work. And I meant to switch over to that from load P2, but I keep finding more things that load P2 I want to do with load P2, and it's so flexible. So I don't know.
Makes sense. I'll try and as an integrator, I'll just try and stay flexible enough to go wherever you go with it.
Okay, so I think that covers our big topics of the day. So we're in the free-for-all zone.
I like how someone's clock is being captured.
You hear the ticking?
Yeah.
It's probably my amateur satellite clock right here. Amateur radio satellite clock. Here's a
like 8 minutes fast or something?
It could be. Of course, amateur radio satellite stuff, they give me a clock that is not synchronized to GPS. Hey, it's a gift. I can't fault them.
It's precise but not accurate.
Yes.
See that Lachlan got away from us, but I was interested in hearing more about MicroPython since it's more active on the forums now. And just kind of refreshing us on what you can do with it, how you set it up, what it can do, why
I think it's
use it.
not really ready for prime time yet. Ray's been bringing it up to date, and he's done some really great work on it. But I think it's still very much in flux. Like he's trying to. It's been a long time since we worked on it, so there's been a lot of changes on the MicroPython side, and there's been some changes on the P2 side and the tools. So he's been kind of trying to reconcile those things. And he's, as I say, he's made a lot of progress, but I don't think it's quite ready for general use yet.
And is that Ray Sadeka or Ray in Australia?
He goes by Rayman on the forums.
Yeah. The visual display Ray. Yeah.
Yeah.
And I know that Damien, the creator of MicroPython, was putting out a new version of MicroPython too. Maybe he already did.
Yeah, that's just come out, I think, and that's what Ray is trying to update to.
Yeah, okay, well, wait, that's exciting.
Yeah, it's it sounds like there's a lot of nice new features.
Well, and I guess we would really need useful, like everything, useful libraries to make use of it, because I wonder about things like driving a display. There's nothing in MicroPython for that, but I suppose with a library we could do this sort of thing, which could make it a lot easier to program for some people.
Yes. Yeah, definitely. I'm sure Ray's thinking about things like that, and I know Lachlan has been interested in it as well.
Cool.
So hopefully it won't be too much longer before it's something stable, but it'll be a little bit.
Since we seem to have a little bit of a lull, I can always show my Hexapod robot if anybody's interested.
Let's do it.
Here. Let me see. I need to switch my camera. How do I do that?
So while you do that, so everybody knows, this is the next big robot project on the forums, which has been
it's been around for a few years. But here it is. It's got it up and running. If you haven't seen it before, this is what it looks like. It's got, looking into the computer level, this has got 6 P1s, the RoboPies, running with a P2 in the middle, and a lot of wiring mess right now. Plus, I've got a lot of debugging information set in here, but It's got let's see where we go. RGB lights here for troubleshooting, and it's also got, let's see if I can get a camera around here. There's a display with the power system. I actually got it plugged in right now for charging, so you see where the key switches and power for everything is at. So I can run one of the apps that I've run for this thing. Let's go. There, it's going through initial startup. Now reset leg 1 to a position, and then that was basically a movement where the leg coordinates all 3 motors together to move the tip of the leg in a straight line. This is all preparatory for the walking. Right now, I'm working on the code for coordinating all 6 legs together using that straight line so that they will move in a coordinated fashion. So anyway, it's coming along slowly. I'm not spending quite as much time on it as I used to before I retired. Now I have other things keeping me busy, but still a lot of fun, still playing with it. So
what's the application going to be? Just fun, right? Making this
just
thing
fun.
walk.
Yeah.
Okay.
Yeah. Learning how to do new things. Got to learn how to do a lot of machining since everything's built from scratch, and also the anodizing, because this is all was raw aluminum that was converted anodized. As you can see, actually I used 2-color anodizing in order, so that was fun figuring out how to do all that. But it's got these are the HB25s, got 18 of those, one for each motor. So
I got a couple questions.
Huh?
I have a couple questions.
Sure.
What kind of power supply will it carry? And does your wife know you're bringing this on your 6-week vacation?
No, it's not going on the vacation, but the power supply is actually had to go to a new power. The battery I had before was a lithium ion that I built from scratch, and I did something to it and ruined it. So now I've got a new one in here. This is a 25 amp hour lithium iron phosphate battery that's in there. So based on the calculations, it's supposed to last me about an hour run time.
What kind of CNC equipment are you using?
Oh, that's right here.
Oh, is that a Tormac?
That's a Tormac 770.
Yeah, okay.
Yeah.
With
I like it.
Flood coolant.
Lots of fun. Oh yeah, and then of course you got to have all the tools.
Yeah.
So
are you going to be able to get this out of your house?
Probably, because I'm going to be selling it because we're going to be hopefully moving in the next 3 or 4 years. So
I was talking about the robot.
Oh, the robot? Oh, the robot's going with us.
Yeah, it can fit through the doors.
Well, the goal would be eventually have it walk out of the basement, but we'll see. I got to teach it how to walk first.
Do you kind of have a plan for how it ought to walk? Like, have you been studying like insect or crab gaits
Yeah, I've been looking at there's a whole, when you go into the various Hexapod forums, some people have come up with a dozen plus different types of gates that it can go. I'm going to go with a simple one right now, which is just a tripod gate, two sets of tripod, so to speak, and it'll be alternating between the two. It's probably the easiest one to program. But there's they have staggered gates where the legs are staggered and things like that. They're kind of neat, but a little bit overkill, I think, for this particular project. So anyway, that's where she is now. Hopefully this winter I'll have some more time to play with it. This last winter got awfully busy, so not nearly as much done on it as I was hoping.
So you mentioned a little bit about the electronics. There's a P2 in there or several propellers?
Yeah. Yeah, you can see where the numbers are along the walls. Those are all RoboPis with P1s. And then buried in the wires right here, somewhere in here, there's a P2 edge and what is it? The mini board or something. I don't know what it's called.
Yeah, the mini breakout.
Yeah. So I'm tapping into several of the lines right now if I go back to the computer. This is so I can, I'm testing the communication systems. Let's see here. Find my mouse. There. So this is just running, and we can see that it's like about every 19 to 20 microseconds, the legs are individually feeding back with what's being sent to it. And if we jump in there a little closer, I don't know if how fuzzy that is or not, but that's the communications that's feeding back to the P2 to tell it each leg is saying, this is what I'm doing. And the P2 sometimes reads it, sometimes it ignores it, depending on what's going on. But it's a lot of fun. And I use the Spin IDE is the one I've really liked doing, and with the debug window at the bottom. I love debug. I just need a Chip, and I talked to Chip about having something where maybe at a method level we could turn on and off debug. That would be nice.
Oh, yeah. Yep.
But so that's about it. That's it. So
it's pretty neat.
It's impressive.
Yeah, it's fun. It's a fun way to spend the money before the wife gets to it.
I could see it looks pretty expensive with the $sign,
yeah.
3 digits, comma, 3 digits.
I don't even want to add it up. It's gotten cheap lately. It's all programming now.
Any questions for Bob? Hey, Bob, what was your background before you retired, if I could ask?
I was in IT, and I started out, I was a nuclear reactor operator in the Navy for submarines. I work at nuclear power plants around the country. Consulting engineer.
Chip's son is going out on the submarine in the Navy. I'm going to feature your robot in our. I'm going to feature your robot in our newsletter, if that's okay.
Sure.
It's very inspiring. When I see things like that, I really want to start another big project myself.
Hey, Bob, I have a question. Kind of unrelated, but I'm just curious. So you want to move within 4 years, and so where do you want to go and why?
I want to get away from Michigan. We're getting tired of the snow. Get someplace a little warmer.
I see.
Sounds
Not in
like
a big hurry, but
Red Bluff,
got to downsize first.
Yeah.
Well, if you move to Red Bluff, California, you'll have access to CNC machines because that's what they are.
Plus, it's super warm here.
Plenty warm.
Yeah.
All right. So who else is holding out on us with something amazing to show and so quietly hiding it from us?
Amazing may be a bit of an overstatement. But I can take you to the junk zone.
Does it include audio?
No. It does include. You probably don't want the audio. It's obnoxious. It does the webcam glitch out? Yeah, I love it. Okay, I think it stopped glitching. Witness the construction that can only be described as whatever the fuck this is. Do you wonder, why do I have to add this high-tech cooling system to my P2 Edge? The answer is because for some reason this P2 Edge is like substandard and will crash if you don't do this. Well, the heatsink actually does nothing. It's all the fan that does it.
What frequency do you run that thing at?
Oh God, I must be 343 or something like that. I have to check it maybe. Where's the file? Where's the file? That would, yeah, 343.6. So it would run for like a few minutes, then crash with the SNES emulator. Which remember previously I've shown it off on the eval, but I've made it work here. But it requires this fan. Now I've checked this with Michael. He has a bunch of edge modules laying around, and none of his do this. So it's this particular module that just kind of doesn't wanna. Oh, he said maybe the room is warmer, but I don't believe that. It's a very cool basement room. Anyways, yeah, it's basically the same as it was last month. As said, I have been disposed. However, if you do launch this, I did manage to fix the main thing that was, well, one of the main things that was causing it problems, which was that that it didn't implement any sort of caching for the code that it's loading from the external memory. So in some cases, there were like screen glitches caused by the CPU cog not keeping up because it was spending all this time loading stuff from the external memory, like at the individual byte level at sometimes. However, now it has been fixed along with a bunch of other nonsense bugs. Look, there's an HDMA effect and it's not glitching. Wonderful. Well, I guess I have to explain why this is wonderful. So this is what's called an HDMA effect, where it's basically setting up a DMA transfer that goes off every scan line. And because the DMA controller is sort of bodged onto the CPU cog, because it kind of just makes sense. If the CPU takes too long for one scan line's worth of instructions, it will sort of shift it downwards. It will not update it in time. But due to the quirk of how the scroll registers in particular work, which is that they're kind of like a shift register, you have to write them twice. But if you only write once, it will end up in this weird shifted state where nothing makes sense. So you'd get glitched lines because it would catch it, the scan line would start at just the moment where it was glitched in between the two writes. It is a whole kind of interesting worms. But now it works. And, can do the thing. Yeah. Well, as a result of this, some stuff now stopped working. It was previously working due to some sort of timing coincidence. So, is it a good thing? Is it a bad thing? I don't know. Can't tell.
Ada, I'm wondering if you could I'm looking on Amazon for like Peltier cooling systems with fans. And I'm wondering, what you should be able to do? You get you might have sufficient thermal connection. It's kind of hard to get on top of the chip because there are other components around it on the P2 edge, but maybe you could because these things are a little big anyway, just stick it to the entire backside of the P2 edge module and cool it from there. That might work pretty well.
You mean like a big heatsink on the back?
Yeah, just put it on the back because you have that giant via array and the chip itself is thermally, connected to that bottom pad on the chip, which then goes through those vias, which are like little heat pipes. So you could probably just cool that thing from the back. And because the back is flat, you could mount something flush to it without worrying about having to home in on an exact part.
That makes sense. Well, again, the heatsink that I put on here actually does nothing. like literally nothing. It's just I've just been too lazy to remove it again. It's all the fan just fixes it. It's really just the forced air on it, and it's just I don't know. I just found this in a box somewhere. Don't know what sort of previous life that one had. Well, if it's in a box, it probably got pulled out of some sort of junk device. Well, I say junk. Most things aren't really junk. It's just like we say it's junk because we don't immediately find it useful. I don't know what English word for that is, but in German we have a very nice word. It's called Wegwerfgesellschaft, which means something like throwaway society. As the society that we live in, where everything gets thrown away.
Wegwerfgesellschaft?
What?
Can you say it again, please?
Wegwerfgesellschaft.
Wegwerfgesellschaft. Well, we might call it stuff.
Anyways, it's this idea that you can just throw something away and buy a new one, which in most cases is true, but it's like, where does all that stuff go that you throw away? And where does all that stuff come from that you buy? Not very nice, that.
No.
Yeah.
That's a good point.
Anyways.
And also, it's really difficult to get rid of stuff. It's really easy to buy it.
I mean, yeah, it piles on in your house because you think it's too precious to throw away, which is kind of...
That's right.
But it's all kind of poorly constructed, so it breaks down, right?
Yeah, it's all just materials that you've ascribed some value to because you paid for it.
In the end, all is junk, and junk is all. Yeah, that's that. The other thing is that I actually did see some improvement in terms of funny P2 software is oh, come on, where is it? Where does it live? I know where its house lives. Work? Yes. That was the Tempest 2000 port that I was doing. Now, last time I was showing this, it was barely working. Now it is almost entirely working. There's a few like oddities that need to be fixed, like the music fading between different tracks, but behold. Silly
Chip, we
shoot
used
game.
to throw some money into that game. Over the chat, got a few things here. One of them is Kevin Ahr is still building his big robot. Kevin bought 2 or 3, asking about any updates to the universal motor drivers. I think not, right, Stephen?
There was a major update a while ago. I'd be interested in knowing if he's running that version.
Yeah, I was testing that version too. I kind of wondering if it's a hardware issue at this time, because when the lines going into the motor driver is totally fine, but the output is just messed up. So I'm not quite sure what's wrong with that.
Let me see if I can find out what version I think is latest. It's been a while since I looked at it. I had a person here in Colorado, I believe, do some major updates, and so I merged his code.
And while you guys look at that, we're going to get Terry Trapp queued up to share a QR code project.
Oh, nice. That was fun to see. Yeah, you should be running 5.0.
Anyways, the jank zone.
Motors. Kevin?
So, Kevin, what you're seeing is the output onto the motors was junk, not what you'd expect?
Yes. Yes, I am running 5.0.
Very good. And is it only under certain conditions, or?
No, it's just random. Like I was running the example for just the regular brush motors, had the same issue with them too.
Hmm. Interesting. Yeah, as far as I know, that code is pretty stable.
Maybe time to put an issue in the GitHub for it and revert to Kevin so he can keep going on his robot to a prior version.
I don't know. I think the other versions are less. This was a major release in cleaning up ramping and cleaning up motor directional control and things like this. So I think it is one of the best ones to be at.
Yeah, what would happen with me is that the motor would just start ramping up and then it would just shut down for like maybe 10 seconds. Then it would start back up and then it would just shut down. So
is it a do you have enough power for your batteries?
Mm-hmm.
So if it tries to draw too much power, it will shut down like that.
What is your power supply, Kevin?
Well, I was using a I believe 15 amp hour lead acid battery.
Yeah, that's that. And what kind of current do you think those two brushless motors pull when they start up? Like 10 to 20 amps or so?
Big, depending on how far you're trying to drive them, it's crazy. Mm-hmm. I had to go to I started using discrete batteries because my benchtop supplies were not, I did not pay enough for high amperage benchtop supplies to drive the motors. So yeah, I'm using like S6s with, big capacity.
Yeah, I'm with you. Power supply is often a problem. That sounds like a reset with big robots. And I've had a lot of resets and then fires with my robots, of course. And lithium polymer batteries or lithium ion batteries might be the way to go.
So you're running 12 volt or 18 volt, Kevin?
I was running 12 volt, but that was on the brushed motors. With the brushless, I had the same issue, but yeah, I'm running 12 volt.
Kevin, do you have a lithium, a LiPo charger?
Not at the moment, no.
I have in Rockland some big batteries that I was using on huge drones that are just sitting there, and I could easily like six cell big amp hours. I mean, they'll provide the current. I could send you one of those if you get a charger.
I would chase that path first to make sure you have enough power before we look at the driver.
Yeah.
You can get a charger for like 20, 25 bucks on Amazon now, and then it's really a matter of the right connectors too.
And the other thing I do is I run they have inline meters for that power system. And so you can take a look at current draw-on wattage and things like this with the inline meters. And so I run that on my platforms as well. That way you can see if you're going over the edge and where it died, what you were drawing when it died.
Mm-hmm.
Yeah, I sort of did some testing with just no load on the motor driver at all, and just manually setting the pins high on the P2. It would just shut off after a little while.
Mm-hmm. Yeah, it's amazing. It's amazing what the ramping can draw if you let it.
I'm using a 7 amp hour 12 volt lead acid battery on that robot I showed earlier today, and it's barely enough, but I'm using the brushed DC motors, those gear motors we have, and those are like 2 to 3 amps. But it's just so much easier to ship a lead acid battery around the country and easier to charge it too.
Yeah.
And they're like not worth the cost of shipping, so we could recycle them after events. It's cheaper to do that and ship them home. Talk about disposable society. I shouldn't have said that. Well, Kevin, if you want a bigger battery, follow up with me, Kay?
Yeah, I will.
Yeah, I got it for you. And then I'll point you to a charger too. But yeah, be really careful with this thing. I mean, you're talking to the kind of guy that has cut the leads off with one set of cutters and one fatal swoop.
Oh boy.
Lesson in welding.
Yeah, I was going to say, brave. And what's the shape of the cutters afterwards? You have notches in your cutters now, do you?
Yeah. Well, they're stuck together still.
Blowing metal bits off of cutters. New experience. Molten metal bits.
Well, Terry, do you want to show us the QR code thingy?
Yeah. So let me see if I can get my screen shared here.
That's fascinating. What took you down that path?
Okay, so the thing that got me going with this was with of course all things with me lead back to my light controllers, right? And whenever I'm out in the yard, testing these things and making sure, I have like different manual things that you can turn on and output and make it a color, and you can check and make sure you have everything configured correctly. I use my phone to do that. So I just bring up the web page on my phone to be able to do it. The problem is I have to look and see what the IP address is of the light controller and type that into the phone. And oh, I didn't put HTTP in there, and it has HTTPS and it won't get to it. It's kind of a pain. And what I want to do is I want to just have a QR code on the display that I just scan with my phone, and I'm on the controller, and I can, I don't have to do a lot of manual, messing about trying to type in an IP address. And so, I started looking to see, has anyone done one of these for the, for either the Propeller or Propeller 2? And I couldn't find that anybody done anything like that. And I'm like, okay, well, maybe this is something I can do. Boy, was I wrong. Because the way the QR codes work is it's just layer upon layer of encoding. So you have your Reed-Solomon encoding. You have basically once you've completely encoded the QR code, then it checks to several different things to see if it's the best QR code that you can display to make sure that it has the best contrast, that kind of thing. And so I'm like, okay, maybe that's a bit more than I can do. Let's take a look at some of these libraries. And of course, every library that I found relied on third-party stuff that's just not available, so you have to have all this stuff. It's like, okay, that's no good. So I started looking to see, all right, who's done this for microcontrollers, and they don't rely on third parties. I found one for Arduino, and the problem was it was just coded really bad. It's in C, and it's a combination of C++ and C. And I just could not get it to work under FlexProp. It's like finally I just gave up. It's like there's too much. And I found another guy that has one, and he did it so that he could show QR codes on his TI-99. And it was for a retro computing project, and it specifically was built not to rely on any third-party libraries. And so let's see here, the gentleman's name, it's at the top of the code here. Yeah, BJ Gilliott. I'm probably mispronouncing that. So I had to do very little changes to make this work with FlexProp. And the really neat thing about the way this works is it has two different ways of doing an output that at least that I can think of off the top of my head. Is one, it will display it as ANSI codes, or two, it will display it as Unicode. And so any display, like if it should work with John's ANSI code interpreter for any kind of display on the P2. And so here it is, just bare bones calling. It includes the QR.C, and I have it set up to display as ANSI right now, which I haven't shown on the form. I have the code for this out on the form for anybody that wants to go look at it. But you just compile and run, and there's a QR code. And if I don't know if you guys can see that.
I haven't seen the screen yet.
Oh, you don't see my screen yet?
I see the compiler, but I don't see the QR code.
You may just be sharing the one window.
Okay, let's see here. How do I say share the whole screen? There we go.
There you go.
How's that?
Better. Sweet.
So yeah, this takes you to a URL that shows you about the P2 on Parallax's site, and it was generated by a P2. So that's what it looks like with ANSI on the output.
And it works. Nice.
Yeah. I was so stoked because it's something I've just kind of tinkered with for the past few months, and got it working earlier this week whenever I found this other library that was like, oh, this is a good library. This is what the Unicode output looks like. If I can run it, there we go. And so there's the Unicode output. And it's kind of neat the way that the Unicode's done, because each character is 2 pixels.
Oh, fun.
Yeah. So those are individual lines that are shown there. So you can kind of see the space in between the lines within the terminal program. Let's see, and somewhere down here in the code, you can change those. I actually inverted them so that they look better in FlexProp, because it was an inverted color set, and while my phone would detect it inverted, it took longer. And so here's where I changed that mapping right there for the for those images, or for the yeah.
Interesting. Each pixel is 2 rows.
Yeah. Each row has two pixels in the QR code whenever it's done that way, and you'll notice. Let's see here. Let me run it again. Oh, it's not going to like that because it was still open. So you can see the size of that QR code.
Right.
Is about half the size of whenever I change it around and do it as ANSI.
And it's the same content. Interesting. Yeah. Wow.
And it's because these pixels are full size. 1 pixel, the height is 1 pixel on the line there.
Wow.
Well, technically, there's even Braille characters that you can use that are like 2 by 3 per character.
Oh yeah. We could definitely do that.
Well, I guess the end goal is to put it on like a little LCD, right?
For my purpose, but other people, I think you can put up to like 4 kilobytes into this thing. And so if you wanted to transfer data out of a display, easily onto like a mobile device or something, it'd probably be a pretty good way to do that. Like if you were getting telemetry or something that, like you needed to get aggregated data for the day where somebody walks around, a shop and has to get information off of the machines. Whenever I worked in a data center, they would have to go do that for, for like the Liebert crack units for air conditioning, just to make sure that they're working properly and everything. They'd have to walk around and manually inspect those things. And something like this would make that kind of thing easy. For any kind of telemetry that required a human being to look at it. And to have verification that somebody actually stood in front of a device, that kind of thing. But anyways, it's not anything super amazing, but I thought it was kind of neat, and it's a new tool for people to use. I'm going to try and convert this over to Spin 2. That'll probably make it a little bit more accessible for people. I am not a C person. I thought I was, and then there are all these things that are built up around it, and the way the things around C make it difficult for me to get my mind around. Spin's super easy just because it's one tool, it's one thing. You're not having to fight all of the ecosystem that's built around it. But
yeah, everything is terrible. If you ever see like a project and oh, maybe I can compile it, and then you see something like that says about something like it's called CMake run with
Oh
all
yeah.
everything
Oh
that your
yeah.
legs have.
Everything I know about make files is /configure. That's it. I don't want to look at anything else.
I mean, standard make files have a higher chance of working. It's the CMake stuff that tends to not work and cause weird issues. So it seems to me that it works better on Linux. I don't know. I guess the system configuration is a bit more homogenized, believe it or not. I guess the likelihood of it just working is increased, but still all bizarre bloatware.
Yeah, even trying to get the one that I found for Arduino, I even went and bought an Arduino to see what that stuff's all about. And even that was difficult to get it running because there or not get it running, but to be able to get debug output because the debugger is only available in C++ and you have to rename files so to compile to C++ and trying to understand all that. It's like, I don't want to fight this. I just need something that I sit down
that's not the good fight.
and lay out.
That's not the good fight.
So anyways, so I hope to get this done. It does use structures in here. The stuff that Chip's done should make that a whole lot easier to do. Rather than trying to, I look at it, it's a multi-dimensional array is what we're dealing with is the hard part, and so you could do that in a single dimension and then have to make do multiplication to make it get to the end of the array and things like that. I could fight through that, but having actual an actual structure available in spin is going to make it a whole lot easier because it's almost a direct conversion at that point. Anyways, any questions?
I have one.
Yeah.
So Terry, I listened to you talk about all that, but I kind of missed like at the front, you said why you wanted to do that.
Oh, okay. Yeah. So I have those the P2 based light controllers that I use for my Christmas display, and they have a little organic LED display on them, and so usually the like one of the controllers I have, it's just mounted on a pole that I have to get down on my knees and take a look at. So if I want to get to the web page that those things display, I have to open up the case, look in there, see what the IP address is of the device, and then type
okay,
that.
I get it. So you want a super fast shortcut way to get there.
Yeah. That way I don't have to type it into my phone. I just pull up the QR code scanner on my phone, look at the display, and it will bring up the web page for that light controller.
I see. You probably know this, but in the debug, there's a bitmap mode, and you can declare if you want square or round pixels, and how many, like I think X and Y per pixel. So you could take, if you just had the binary for one of those codes, you could display it really easily using debug. But I know that doesn't solve the problem because you want to do it on the display itself. But for debugging, you could use that debug thing.
Yeah, for a demo, absolutely. Yeah, that'd be super cool. I got to tell you, man, just the stuff that I was doing a couple of months ago with that, using the debug to draw images and things like that. That debug is so nice. And once I figured it out, I kind of understood the way you use it. It's so easy. I mean, it's really nice.
Cool. Yeah, that was for that laser at the galvanometer.
Yeah. And it was able to render those files. I was just and the thing about it is that was one of those kind of projects where you don't know what you're trying to render and you don't know if it's going to be right, and then whenever it runs correctly the first time, you're like, oh wow, look at that. This is what I've been trying to make it show.
Cool. Good. Well, I'm glad you got some use out of that.
Yeah. Oh, absolutely. And that's the other reason why, no offense to Eric, your compiler and everything's cool. I just don't think that way. And it's like if I can get this into Spin 2 and be able to use that debugger, there's all kinds of cool things that I could, that you can kind of do with that.
Yeah, we could add more types of debug windows as well. I haven't had any ideas for that lately, but all those things are just products of ideas and wanting to see data visually.
It certainly provides all of the best ways to be able to do that kind of thing. It's like just being able to, it's like you need to do graphs, or you need to. I wound up actually getting performance data and was overlaying it over the graphics that I was drawing. It's just like, oh man, this is great. You can make it actually look really good without having to know a lot of details about how it's being rendered. And you just say, put this type of object here on this part of the screen, and off it goes.
Man, you know what? That makes me think maybe we should be able to composite different debug windows together. With like if you want it pixel for pixel, make them all the exact same size, but otherwise it could do a stretch draw. Although, stretch draw is kind of crummy under the Windows API because it doesn't do any kind of scaling. It just says, what integral number of pixels do I use to repeat this pixel? So that doesn't work well, but we could.
I think there is a way to make the blitz smooth. I'm pretty sure there is, but I don't know it because I've never done it. I just know that
the
there's
hardware can do stuff like that.
No, I think that it can do things like that because I've seen some interesting behavior from certain programs. Because I'm fairly certain this smooth stretching does not work on Wine because I have a program that has like a bug with that. I don't know what, but it's certainly possible to change the behavior.
Yeah, maybe I could make something to kind of composite debug windows together so you could, if you need a plot window for random text and shapes, but you also need, I don't know, what would you call the vector scope? You could have that too.
My main problem is actually that if you add that much sort of debug stuff into a program, it starts slowing down to like a speed where it's not useful anymore.
Right. Yeah, everything that runs on Windows for all that debug stuff, it's actually drawing into the display memory, 24 bits per pixel. And I have like super optimized code that it'll do a move if possible, or a fill, or if it has to do one pixel at a time, it'll do that. But anything that looks like it could do a run of something, it then uses something to do like, a portion of a line or so. So it's all as fast as I could figure out how to make it.
Well, it may not actually be that fast, depending on what sort of function you're using to do that. There's some very odd things like that. I think the fastest way to fill into memory on an x86 is actually to use the SSE registers, load them up with a broadcast value, and then store the SSE register a bunch of times.
Oh,
this is inexplicably faster than the actual fill instruction. Because the problem is that the fill instruction has all these weird modes that it can operate in. And I guess they just didn't bother making it work properly. I don't know.
Yeah, I just used Delphi. I didn't resort to assembly language for any of that stuff because I didn't want to get, design in platform dependence. It just needs a memory buffer for a 24-bit per pixel display.
Yeah, that's
or
fair.
bitmap, I mean.
A bitmap, of course. Speaking of funny graphics, I haven't worked on any interesting things other than the Tempest port, which involved some interesting gymnastics. That actually does draw a bunch of go-route shaded polygons and I actually had to fix the algorithm because the original one was buggy and was leaving like gaps between them. Like you can see this even in the original version. But this one does it less. You can see this.
Oh.
that there's a fill bit inside the lines. And
oh, that looks pretty good. You could, those lines are not blended though, right? They're just like solid pixels.
Yeah, I think we had this last time. The problem is that blending CRY colors is kind of dubious.
Yeah.
And if it wasn't CRY, I'd have to change everything to draw in 32-bit mode, which would double the DMA load, which is not good. Or I'd have to change it to 16-bit mode, which couldn't do these smooth gradients.
I see.
CRY is 16-bit, but it can do gradients. That's the weird thing.
Hey, Ada, do you think if we made a board, this is just hypothetical, but let's say we made a board that had like an array of P2s on it that could then, you know, can you envision a simple way to divide up tasks like these that would just take advantage of separate
You mean
chips?
something like screen display? Well, that was invented in the 90s by 3DFX. And the basic idea is scanline interleave. So basically, each odd and even scanline gets split up between the two chips.
Oh, okay.
And back in the day, they did that with, if you had two Voodoo cards in your computer, you could install a little extra cable between them, and that would sort of make them communicate to perform this. That sort of died out because eventually on the Voodoo, this works easily because the Voodoo is stupid. It can only draw triangles to the screen, and you can poke pixels into the screen as well, but it doesn't really do anything. You can't really do anything else with the screen, because the trouble that springs forth from that approach is that if you want to read what you just drawn back in and do something with it, well, one half is on one card and the other half is on the other card, right?
Right.
So that's kind of a bit of a pernicious thing. But if you just draw it straight to the screen, that works. And of course, you could divide something like that in many other ways. I mean, you already should have to divide it between cogs. This does nothing of that. This just uses one cog to draw everything. I say one cog to draw everything. This stuff here, this score up there, this actually gets drawn to a separate buffer and then gets composited in real time. But just don't think about that too hard. It's kind of cursed.
Yeah. Well, I wonder if we made like, what if we had a little board that had like a 4x4 array of P2 chips on it with some kind of like pin sharing, and they
4x4, that's a lot of them.
Yeah. Well, yeah, I mean, you got to have like an order of magnitude more to make a real perceptual difference.
I'd say you could actually do a big difference with just two, because one of them would have to be bogged down with all this nonsense, like the screen and whatever the USBs and the audio and whatever your input devices or something, so you can make it interactive. And then you have like 4 cogs maybe left to do the actual work.
Yeah.
If you add another one, then you actually, well, you don't really free exit, but you kind of double it up. Yeah, it's more than double in some sense. It's kind of hard to explain that.
Yeah, we could also just do it by having a lot of those P2 edges together.
I mean, I'm thinking you can do a lot with just the one propeller.
Yeah.
If you play your cards right. I've been thinking some more. You don't actually need to do vector transformations with anything 32-bit except the translation component that you never multiply, except when creating new matrix. The precision doesn't actually matter that much, I think. So you could have the 9 components that actually get multiplied. You could have them 16-bit, and then they'd be very fast to multiply with the ALU multiplier. And you just need to store a shift value alongside that, so that any scaling operation that affects the scale of the entire matrix doesn't just can happen without destroying the precision.
Right.
But other than that, the usual operations, which are translation, scaling, and rotation, don't actually need to have that much precision, I don't think. So that's a good way to get away with less. I've also been thinking about how can you do the texture mapping. I think I've just brain dumped that somewhere into a Discord thing. Right? Let's see if loading that will explode my computer. You may have noticed that normally I join like at the beginning of the meeting because I don't know, I have basic time management skills, believe it or not. It's hard to believe. But for some reason the computer exploded and I had to put it back together. And that's why everything's closed right now. Let's see, can I find something that I wanted to find?
Excuse me, just for me. I've passed the host to you because I have another meeting at 3.
Me?
Yeah, I made you host and you can end recording whenever you want.
Okay.
All right, thank you. Carry on, Ada.
All right, thanks.
So the funny is I've been trying to figure out how fast can you actually plot the pixels if you want to. Of course, we know the upper limit for that is sort of you can write 1 long per clock cycle if you're just filling with a solid thing. And that has been realized, of course, with the funny hexagon thing. But I've been thinking if I want to map a text, there's go route shading. But look, it's all smooth and nasty. But if you want a texture, how much does that cost? The answer is possibly just a few instructions, because you can do a little silly thing where you put multiple values into the same register, and then you can add them at the same time. This makes no sense when you think about it, but this makes no sense when I explain it right now, but there's some code that you might have that, I don't know, does this do code blocks now? Does this do formatting? Let's see if ow, sorry, I dropped the microphone. Does this look like a real code? No, this doesn't. But it gets the idea across, right? Which is that you kind of just need 4 adds, and suddenly you get you can interpolate the texture coordinate.
Oh yeah.
And already have it as an address that you can just load from. This sort of abuses the 12 unused bits at the top of the address, because those get added too, right? You can, even though we don't normally use those in calculating an address, but we can get the carry out from that and say, when there's a carry out from that, we advance to the next scan line in a texture. Some oddity here might need to be done to actually, maybe not, maybe it doesn't. I think I thought about this. I don't think you actually need to change this from an add into something else even, because you can subtract in the thing. We kind of have to wrap your head around. It's kind of a bit unusual, but this does work. But it has the limitation that any value must stay bounded. It can't wrap around, because then it will wrap into the other values of space. But if you make it so that doesn't happen, you can very easily do that. Now, that's just for linear interpolation across a sort of across a span. Now, the other thing that I was thinking, is it that difficult to add a perspective component to it? Because the problem that this solves here is that we need to increment in amounts smaller than 1 with a fraction.
All right, let's use fixed point.
We need to, what?
You could do like some fixed point, like 24.8.
Yeah, the problem is when you do the fixed point, you have to sort of shift it all the way around to convert it into an address in an array, right? And you kind of want to avoid that. So what I've also thought of is if you want to interpolate with correct perspective, you actually want to interpolate not just the U and V, you want to actually interpolate the U over Z and the V over Z. And along that, you need the reciprocal of C.
Right, so for like 3D perspective.
Yeah, exactly. You need all these, and then you need to divide the first two values by 1 over z that you've interpolated, and then you get back the actual value at that point. Now I'm thinking, if you scale this right, then the divider spits directly out of the divider comes an integer, because all that subpixel precision gets discarded by the division if everything's scaled correctly. So that avoids the nasty shifts. So after the division, you just need a multiply and 2 adds.
Hey, well, maybe you could make like a double integrator that takes care of the division problem progressively as you calculate your progressive points, so that it'd be kind of like how can I say it? But if you double integrate rather than single integrate, you might be able to like sublimate the division into an additional add step.
Yeah, I think that should, if that was possible, I'd have read about it somewhere, but I didn't. So maybe that's something that no one has come up with or something. Because right, the thing is that that both the divider and the dividend might move into they're both interpolated, right?
Yeah.
So we've kind of got them moving differential to each other in sort of uncorrelated.
Oh yeah. The distance is changing each pixel, but because you're rendering a polygon, there's some linearity there at some integration.
Yeah, that's the thing. All the something over these are all linear.
Yeah.
And I haven't seen it without needing to do 1 division per pixel that needs to be plotted, which is, well, I guess in this case it would be 2 divisions, but because you need the U and the V.
Yeah. In the P1 hot or the P2 hot that we were working on was going to take too much power. That thing had a divider. I want to say, did it even have 2? I think it had 2 hardware dividers for looking up pixel or looking up the coordinates for textures. And it was like not super high resolution, but it had to operate like 1 per clock. So I forget the whole thing, but it was not complex at all. But yeah, we did a division every pixel. Actually, I think we did 2 of them.
Yeah, if you pipelined, you can do it quite you can do 1 per clock
Oh
cycle.
yeah, then you could just use the Cordic to do it.
Yeah, I mean in this case, my guesstimation, I haven't actually written anything, would be that it's something like maybe 30 cycles per plot when it comes down to it. Maybe some extra overhead for edges and stuff, like for edge iteration and stuff like that. But if you calculate that out, give me a better calculator than this. The only calculator that is good is the one that's not a calculator. Have you ever noticed that like the Windows built-in calculator sucks? And that like the built-in calculator on every operating system sucks because it tries to emulate like a basic 4-function kind of calculator? Like you ever see like a real calculator, like a Casio FX something? Those don't work like that. Those just have like a thing that's more like a command line where you type in your expression and you press enter. And then it types out the results, and then there's like a little history. That's what like a real calculator does, but that's not what that does. So let's say we have let's inflate our estimation to like 40 cycles per pixel. So if we have say 2 cogs working on such an oddity, then you'd get something like 320 by 2 is 640 cycles per second, if you divide 640 over 40 cycles, then you get about 16 megapixels per second fill rate, which is actually quite good. That's at least well, it's kind of okay, but that's with 2 cogs, which is just saying maybe we need half of the time for something else. If you went with 4 all the time, that would give you twice of that, which is 32. Which that would be on par with like the old original PlayStation. That allegedly does like 33 pixels per second. Actually, no, it does between 33 and 16 and a half, depending on how texture cache is doing at the moment. If it's cached, it needs 1 cycle. If it's not cached, it needs an extra cycle. Though I don't think they ever actually get to that theoretical maximum, at least with the usual sort of way that it is. I think it actually spends more time doing other things and not actually drawing anything. Because have I ever heard of S3 Verge? This was like terrible video cards from the 90s. Those had a fill rate that went, if you enable all the features, went down to like 5 megapixels. And yet still it can play the original Tomb Raider at 30 frames per second. So clear, then that was originally on the PlayStation, right? If it's like 16 to 33 megapixels. So clearly it doesn't do that, at least not when it's running Tomb Raider. I mean, the Verge probably does not reach its 5 megapixels either, because there's a bunch of software overhead in the driver probably. So you probably don't even need that many pixels. I mean, you can calculate the how much depth complexity that lets you have, right? So if you have your 16 megapixels, you could have a and want to run 320 to 40 30 frames. That would result in a math error. That results in a depth complexity of almost 7. So any pixel could be overdrawn like 6 times and then some. Which also you think you muted yourself and didn't unmute yourself. So basically, if you have 4 cogs with a pessimistic, 2 cogs with a pessimistic estimate, you can draw over every pixel 7 times per frame, and it will still be good enough, I think. Of course, you'd want to avoid actually overdrawing that much, which you can do with if you're smart about it, right? If you have like a wall or something, you can build like a structure that tells you that all the stuff behind that wall should just be skipped over quickly. There's many ways of doing this. But what I've sort of been playing with in my brain is to just divide the screen into little cells and then have like a low resolution version of all the geometry that just draws Z values into those cells. And then when you want to draw something, you can check against those cells which it falls into. And if all the cells that it falls into are have something in front of them, then you can just skip the entire thing.
Yeah.
Something like that. So yeah, that's the sort of brain rot that we get up to here. And also Tempest. That one's not yet ready, but even though I really wanted to get it done before today, but so I could say, oh no, look at the shiny new thing, but it isn't done. I know, I got held up by other things. Eric made the loader capable of loading into Flash. So I was thinking, what if you could build a flash file system image on the PC, so you can upload files into the flash file system without so much hassle. But I don't know, I couldn't get that one to work. Was that just a line clipping bug? Oh, it happens when you show it off. That's when all the bugs happen. Like, was there a line clipping bug now? You're still muted, by the way. I can't hear you.
Okay, sorry. I was just explaining to my friend Bud here what you're doing.
I'm playing Tempest 2000 for the Jaguar, but it's no longer for the Jaguar because it's a native P2 version. I say native, but it's really just like it still has the 68,000 emulation in it. But all the other stuff is for the P2 now.
What is that on?
I was on the Atari Jaguar originally. Ever hear of that? It's like known to be very terrible.
And now it's emulated on the P2?
No, I just ported the game because that's like
you ported it?
Yeah, because the source code has mysteriously appeared on GitHub.
Huh.
Well, it's been mysteriously floating around for several years, so.
But you're emulating it, right? It's not running in any kind of native assembly language.
It's emulating the 68,000, but more like an interpreter sort of way. Like it's not emulating any hardware around it. It's just interpreting the 68,000 instructions and letting them access memory as if it was like a native program.
I used to play Tempest back in like 1980 when I was 13, and that game was like really fun because it needed it was very responsive, and I don't think any modern console is going to do justice to what that game was originally like.
Yeah, I think
it had a turn, what do you call this? Like a
it has like some sort of rotary encoder.
Yeah, and it was very inertial, and it was like super sensitive, and the latency was, really low because that was at the time a vector graphic display that was
this was
maybe
quadro scan.
Yeah, it could have been doing 100 and it was variable, but I think maybe 100 frames per second.
Yeah, it does.
Because it was just drawing some lines, but it made the game a lot of fun to play.
Yeah, this does not have the it's just raster graphics. It does have some nice effects in exchange for that, but and it would support a rotary encoder. I didn't hook it up for the P2 version, and it never manufactured an official one for the Jaguar either, but there's support for it in here.
Well, yeah, there were levels too though that were like invisible, so there'd be no shading at all.
Yeah, I mean, normally you wouldn't have the level like this at all, right? This is just something they added for this version. In the original, it's just the lines, and I can, if I bother reloading it, because that's faster than losing all my lives, maybe. Because this does have a traditional mode that's more like the original. They even make all the objects out of lines instead of polygons, which is very interesting. That goes through a completely different drawing routine. Also, the camera gets offset. How nasty. Nice thing about having a low resolution camera is that you don't need to worry as much about pointing it at things that one shouldn't see. And why is it stopped loading now? Oh no, this never happens. This just happens when I try to show it off. How nasty. Oh. It just takes this long because it's loading over the serial file system. If it was loading from SD card or flash, it would be faster.
Dave Plummer he's got a YouTube channel called Dave's Garage. He used to be like really, really good at Tempest, so he bought his own machine.
I was good at it too, but I was young and I was like my I was faster twitch in my response to things and my perception. I don't think I could play like I used to.
Yeah, it'd be cool to run your version by him and see what he thinks. Because I don't know what his scores were. I never played it myself. Because arcades were just we were 9 miles out of town, and the closest town was like 600 people, so we didn't even have one.
Anyways, there's traditional mode. As you can see, there's no shading on the level. It's just see-through. And all the graphics look a bit more like the original arcade version, but it's still kind of crummy because they're drawn to like a low resolution bitmap instead of being a vector. But it does have the star background going for it. That's just going at all times in the background. Just because it can.
Did the original game draw vectors on the screen?
Yeah,
well, the original Tempest, but this is Tempest 2000, and then I bought the Tempest 2000 to the P2. So there's like two levels of original. It's like a tertiary work, if you will.
I think that original Atari game was super tuned for the hardware and the playability and so you would interact with it in a way that probably could not really be replicated today, because when you get into those higher levels, you have like, I don't know, 10 milliseconds in which to respond. You got to time your movements super carefully. And there was a lot of like analog in those short intervals. And I think everything that would try to do this later, it's not gonna, you wouldn't get the same kind of Tempest experts even being possible that existed back in 1980 or whenever it was.
Yeah, I mean this is popular in its own right, but funnily enough, the P2 version actually runs really well. If you play this on the Jaguar or on the Jaguar emulator, you'll notice that there's quite a bit of sort of timing drops that does not update at the full frame rate, which is very funny when you have the jump power up, because it seems to be mostly bound by the by how fast the GPU can run. So if you jump away from the playfield, everything gets smaller, it draws less pixels, and suddenly the speed increases. Well, not the speed, it does compensate for the speed, but like it becomes weirdly smooth. This P2 version here that I made does not have this issue because it is always smooth.
What resolution are you running?
That's a good question. The monitor output here is 640 by 480. The actual internal resolution is actually 384 by 240, which means that there's actually stuff left and right of the screen that you can't see. I don't know why it is like that, but it is like that. That's how it's programmed to be. If you connect this to an HDMI display or a monitor that's widescreen and you set it upright, you can actually see those extra pixels, or sometimes they contain like slight oddities. Everything you need to see is in this 4 free frame anyways. But it is technically 16 by 10, the actual rendered image. It just gets cut off because the monitor,
So in the original game, there was no rasterization. It was just driving the
well, which original? The original Tempest or the original Tempest 2000? There's a big difference.
Original.
Yeah, that one was just raster, just vector lines being drawn. I mean.
Yeah, it was just hardware drawing vector lines.
Yeah, just directly controlling the yokes on the CRT.
That'd be cool to do that.
Yeah, if you ever see a vector game in person, you can tell that it's a vector game. Like it looks very distinct.
Right.
And that was actually quite popular for like a certain period of time. They even made something called the Vectrex. By they, I mean I think it was like I don't even know who made that one anymore, but that was like a little thing that you could buy for your home, and where they basically had like a small CRT built into the device, and then it would play these little monochrome vector games on it.
Yeah, I've seen one down at the Georgia Computer Museum. It's pretty cool. Actually,
yeah, that's like
hands-on one.
That's quite also I think it used like a 6809 CPU, which is bizarre and strange and rare. So that's kind of an interesting system all around. And yeah, that's
It's kind of interesting talking about the vector stuff. So something I looked at doing was actually trying to do a direct conversion of asteroids to P2 and have the vector output drive my galvos on the laser.
Oh, that's that.
Yeah, you should be able to do that.
Yeah, I think I've seen someone try something like that. Problem is that the deflection on the mechanical deflection on a laser isn't quite as fast as the electromagnetic deflection on a CRT, so you'd get all these kind of curvy lines instead of the sharp the straight lines.
Yeah, I was really surprised, like running some of the tests that they have that basically how many points was it points per second, and I was able to drive that thing up. I mean, it was into the tens of thousands of points per second. I was surprised at how well it could handle like even some of the things that should only drive like professional type laser stuff. I mean, the P2 is able to sit there and spit that out and make it render appropriately.
I mean, you could try getting some funny old vector games on a laser. That would be kind of funny. I mean, you could probably, if you have something that can do colors, you could even do the actual Tempest game.
See, now
you could probably even do it without colors, but it would be kind of lame.
What's happening right there is not how the original game works. See, you could hold down the button and it would stream out so many bullets, but once so many left that you'd have to recharge a little bit. So in some cases,
yeah, it does that. You can see the gap between it, but it's kind of too small, right? I've noticed that myself. In that sense, it kind of gets a little bit easier.
Yeah, you had to shoot carefully in the original game.
Yeah, but if you actually play the 2000 mode, it kind of gets a bit crazier if you get the laser power up, because that kind of shoots even more continuously. But yeah, it's kind of a bit jank that you can just sit here and have all these guys come at you. It's very rare that they actually get you.
Yeah.
Like you can do that in the original, but you have to fire at exactly the right moment. So Tempest 2000 kind of doesn't do that right. Then again, maybe it intentionally made it easier. Because it's
what speed are you have you calculated how fast you're emulating the 68,000?
In this case, no, because well, for one, there isn't really an exact speed equivalent, because there's some instructions that the P2 needs to do quite a lot of cycles on that the 68,000 is relatively quick at executing, like even something as basic as an add instruction. But then there's instructions like multiply and divide, which the 68,000 needs many cycles for, but we can just do very quickly because we have fast dividers in comparison to that, right? The other thing is that this is kind of more optimized than the original Mega Drive. So it originally developed this for the Mega Drive emulator, and that kind of needs some memory mapping, right? So we say, okay, this is where a virtual RAM and this is where a virtual ROM is in the P2's memory spaces. So it has to kind of do extra work. This doesn't do that. If you write to memory, it just writes to that memory. It does have the thing where if you set bit 31 of an address, it becomes a PSRAM address. I didn't implement writing to the PSRAM, but it just can read from PSRAM, and that's where most of the code goes.
So this is only using hub RAM?
No, this is using PSRAM for all sorts of things.
Oh, okay.
The
RAM and the ROM mapping is for the game runtime. Is that just hub RAM?
Yeah, basically, if any address that's below that doesn't have bit 31 set is a hub address, and any address that has bit 31 set is a PSRAM address. It only needs like about 4 megabytes or something of PSRAM, and that's with some stuff added in that wasn't there originally. So it doesn't even need the full bandwidth from here. For some things kind of slow down if you don't have the fast memory on the P2 edge.
Is it much of a performance hit to stream instructions out of hub RAM versus executing directly from cog RAM?
Well, that's you think you're talking about the wrong thing. That's like you're probably talking about hub versus PSRAM, right?
Well, your 68,000 emulation itself, not necessarily your 68,000 instructions, but your P2 instructions. Do they?
Yeah, of course, in actuality, it kind of depends. If you're just running code that's like straight line without branches, the hub execution is the same speed as cog execution. But any branch that goes into hub RAM is slow and awful. And also there's some things you can't do in there. Additionally, if you do any hub memory read or write that's other than the actual instruction fetch, it also can be slow, or sometimes maybe depending on the alignment of the planets.
So theoretically, you could tune your 68,000 emulation based on the program run so that the most used instructions are, it would build a emulator that has the most used instructions.
I mean, that's just how it works in general. All the most common stuff is in the cog and LUT RAM, and some of the like weirder stuff is put out into the hub RAM. That's just how you make that.
Right.
You make that happen.
So what was the original Jaguar and is as far as 68,000 performance?
Yeah, the original Jaguar has like a 13 megahertz something 68,000, but that's just the main CPU. It has a GPU, which is a RISC processor that can do single cycle execution of 32-bit instructions. And that's kind of what does pretty much all of the screen drawing. The downside to the GPU is that it only has 4 kilobytes of its own memory where the instructions have to be put. So you can only load these small microcodes into it that like do one thing.
So is that a neighboring cog that you load across the?
No, the GPU is entirely replaced by a high-level equivalent where I just took the original drawing code and ported it over instruction by instruction. Maybe I can re-demonstrate that. I had that. I did that last time, but maybe it needs to be done again to sink in really. Let's see, what do we get? So where do we have? What do we get? What do we get? Let's check out this one. Just because we can, maybe. I don't know. This is me. I don't know. This is annoying. Give me one that looks like, yeah, give me the Starfield maybe. That's normally in well, that is normally in you see, I have my brain is so big I can remember that which weird name corresponds to which other weird name in the source code. So I know that llama.gas should be the one that has maybe the star field in it. Does it? No, that one just has this. What the fuck? Oh man. Where are all my registers? No, there's Starfield. Okay, it just lives here, somewhere in the middle. Very odd. So anyways, that's the Starfield microcode. Why is it in there twice? I don't know. But we can find where the equivalent is. There's the Starfield microcode from llama.gas. And there's some stuff commented out here. But you can kind of maybe there's streak loop and there's streak loop. You can see that streak loop here and streak loop here are kind of the same thing.
So streak loop is a call to microcode, and then you emulate.
No, the streak loop here is a label here in the microcode. You can see that that's just the loop label.
Okay.
And this is what draws the star background that sort of comes at you. And there you can see the divisions that are needed for that. You can see those in here as well. Yes, some stuff that I do differently. Most notably, some of the way that the clipping works here is kind of jank. I think Jeff Minter, when he was writing this, was apparently unaware of the carry flag, or maybe it's like buggy or something. But like it's always checking, is the coordinate negative or is it larger than the screen size? When you really just need to do one unsigned check against the screen size, because any negative value would then also fall outside the bounds automatically. And that's of course what I do, but where do we have there? We've got your actual clipping, and then you've got your coordinate calculation, and then we just write a word that has the pixel value. Of course, what the pixel value is gets determined up here, which is nice because in CRY space, you can kind of change the brightness very easily. That's like the one thing that it does. So yeah, that's kind of, there's many, many lines of this stuff. It makes my brain hurt. The bottom we might have, yeah, it's almost 5,000 lines of graphics code here that I've ported over, which is mostly an easy task. But if you look at the original assembly,
emulating the GPU.
Well, no, it's not emulating the GPU. It's just doing what the GPU would do.
Okay.
Or in some cases, what the GPU wouldn't do, because I fixed some bugs in this. And there's also this line clipping bug that I added because, you know, that's what you do.
That's run on a different cog, I'm guessing, right?
Yeah, this runs on a different cog, but it's kind of stupid because the main code always waits on the GPU task to finish. So it's really it would be done by one cog if you wanted it to. It's all very, very stupid and silly in that sense, but it works. So let's not think about it too hard. As you can see, it kind of, so that's the Jaguar version of the code where it falls into this GPU run and GPU wait routine. I didn't bother with this. I just for the Propeller version here, you can see this is if-def. I just write something into the GPU mailbox and test that until it's done just in line, which should be faster based on how the performance characteristics of the 68,000 interpreter are. Because then it can this sort of idle loop it can do very quickly. But a jump somewhere else would take a long time and take memory bandwidth. The most nastiest and annoying thing, of course, in all of this is the sound part, because the source code for the sound part doesn't exist. So I have to write one from scratch that kind of does the thing. Which really doesn't sound that difficult. It really just plays sound clips and it plays mod files. But did you know that mod files are awful? And everyone hates them and bad? Why are they like this? Why? Needs a lot of code and a lot of brain hurt. And this is far from what a correct mod player would be like. This just kind of works for what it needs to do, but now you might ask,
are you outputting the HDMI or analog out?
This is just analog. I still haven't gotten on to the HDMI stuff. Very annoying, I know. But such it is. Anyways, crappy mod player. I don't know why they put mods in here. Mod files that you'd use on an Amiga. But they did, probably because it was easier than figuring out something that made more sense. Because then you'd have to like write some sort of editor. And surely you can't write an editor on the Jaguar itself. For one, it's a giant shitbox that's like barely functional, and it doesn't have any sort of keyboard or something like that. So you can't write an editor on Jaguar itself, but the weird DSP software programmable thing is kind of null at the time. So you couldn't just like have another machine sort of pretend this. So you have to have like maybe something that links them together. So they didn't bother with that. They just made a player for Amiga files. And that's how they ended up with that. Yeah.
Yeah, imagine how much more resources you'd had if you didn't have to emulate these old things. Like when you programmed the P2 to do some games, I'm guessing the original Propeller, I've seen some of your games, and I'm guessing you probably had plenty of CPU overhead or spare cogs to get other things done if you wanted.
Well, on the original Propeller and as on the P2, you kind of get into the same problem, which is that you probably want a group of 4 cogs to do your graphics. And then you kind of have to cram everything else into the remaining 4 cogs, and it never fits because you really would want 9. 9 would be a better number, but of course that would be a very silly hardware design that it would lead to. But there's always exactly one too few, so you kind of have to figure out some bizarre combination. Like, oh, can we cram the SD card stuff into the main cog? Or can we cram the audio into the video? Can we cram the keyboard into the video? And interesting solutions like that.
Ada, do you think if you had a board that had an array of P2s that you would start experimenting a little differently?
That I would what?
If you had a board that had like an array of P2s on it that you could program, selectively or all together, that'd probably you'd probably try doing things a little differently, right?
Well, yeah, you'd have to distribute the stuff again across the multiple P2s, which you kind of have to think how do they even connect them together so that they can share the data.
Right. Yeah, I wonder if you could have, you know what a hypercube is?
Yeah, like a tesseract, like.
Yeah, well, there's a like multi-processing connection array or a connection scheme called hypercube where you have maybe let's see, 8 cores you have like a 2 by 2 by 2 array of cores, but they're hooked together so that everyone is only one away from everyone else maximally. But in this case, we don't even care. We could just we got enough pins. We could just make some parallel buses, maybe make some shared memories, some common memories, or make it so that the memories could be accessed however. Like if we did some 8-bit buses, you could have like 4 of them. And then you could write code so that the processors would coordinate the IO pins to run those separate memories at different times with different people, different chips accessing them.
Yeah,
so
if the memory is shared, then it's a lot easier because then you can just grab stuff.
There needs to be some kind of shared memory because that's where everything ties together. But yeah, I wonder, it might
I
be
mean, if you just
fun.
grabbed like 2 or 4 together or something, not 2 or 3 even, then that would already kind of do something interesting, I think.
Yeah, it'd be kind of fun. I mean, the connection between chips is not as intimate as cogs within one chip, but you could, break it at the memory and have it. It'd probably be like kind of a fun thing to play with because there'd be lots of new arrangements possible.
Yeah,
you just
I think you'd want to get something going on one chip first, and then you can scale it, right?
Yeah.
If you just think that
at least 2 chips, maybe 4, maybe 8 or 16.
Because when I was thinking about the graphics rendering stuff, I always think that it should have some sort of like a job architecture where there's a main cog that runs the like logic and it like gives jobs to the workers.
Yep.
That they need to do, and those would have to be processed in batches. That would actually work quite well if you just added more chips to it. You just distribute the jobs across the chips more.
I mean, like a graphics pipeline where
yeah, the main problem is that some things would have to have some sort of buffer. So some things you couldn't really split across chips. Like if you wanted to do geometry processing, you kind of need a cache of all the vertices, and they'll kind of need to be stuck together. And but you could probably just process one object and then have the other cog process the next object. The other chip process the next object, because those don't share memory, other than the output memory, which is kind of a different concern because you need to output the ordering tables into the shared memory.
Yeah.
Maybe you'd have to do some sort of like bus sniffing to figure out when which ordering table gets stuff written to it.
Right.
Have you ever looked into legacy SGI graphics pipelines?
No, but I've looked into a lot of old graphic stuff, but SGI didn't come. I mostly looked at the like really low end stuff that came out earlier. I mean, I've mentioned the funny S3 Verge cards earlier. Those are very funny because they you put a triangle in it, very, very slowly rasterizes it into VRAM.
Who you're talking to, Doug Mashek, he knows a lot about SGI stuff.
Yeah, I've got the big iron hardware. I work on it, and they're really a pain in the butt to work with nowadays because they're so complex, and there's so many socketed chips and capacitors gone bad. But like for instance, an Onyx desk side with the high-end graphics, which is like Reality Engine 2. So you could have up to like 4 R10000 main CPUs, and they're connected to an E-bus to RAM. So you can have up to like 2 gigabytes of RAM in a desk side and 4 processors. And then the E-bus also connects to a IO4, and then that bridges to a high-speed VME type connection, so that then you have an array of 12 i860s doing the floating point geometry engine stuff, where they take the the triangles from the main applications run on the CPU and turn them into, well, they do all the floating point triangle operations. I'm not sure what what they do, but then you've got raster managers, which handles texturing, and then you got the display generator on the output, which can give you up to 8 CRT type displays. But the way it on the older machines especially, you can see that how their pipeline works from geometry engines are in parallel, raster managers are in parallel, and then there's one display manager. So if you could probably do the similar thing in a set of P2 chips. So your bandwidth in between is completely doable with as many pins as you have on a
well, my thought is really you should really get something good with just the one, especially with how expensive these like are. They kind of have to pull their weight.
Yeah, I know what you're saying. I personally think I think somebody should make a hat for a Raspberry Pi on this and then run so you can do all the real-time stuff in the P2s, all your low latency inputs and stuff in the P2, and then just farm out the HDMI generation and the audio over HDMI.
I mean, that's obviously if you just want the power, you go for something like that. But that's not funny. That's not that what is forgotten and have passed into fantasy.
What's that?
Nonsense that I'm talking. You know, the funny thing about putting the thing on something like this is because it's funny to put it on there. Like if I wanted to play if I wanted to play Tempest, I could do it on the actual computer. But you know, in the fact I do that, but like look, the computer, it can do, I don't know, it can do GLX gears.
Right. But you never get the latency on PC running Windows or Linux.
Well, you don't get the sort of consistency really. It's kind of it's all jank all the way down. That's the problem. But really, it's such a thing. It's not. You shouldn't really think that there's some sort of superiority. You should just do what you think is funny. And if it has some sort of unique advantage, you can haha about that. But it doesn't have to have any sort of actual advantage. It just needs to be funny. It is an advantage in itself. And thus Tempest 2000 for Propeller. That's just sort of a self-evident truth. It exists and it runs sometimes. I mean, we also have the what else do we have? I haven't shown that one in 5 minutes, so I have to load this one up now too because where is it? Oh, come on. Edit spin file, edit spin file. That's already set up correctly. We just have to change this to something else. Oh, nice. Let's hope we don't have a flex blob happen to us. Such a thing would really be quite unfortunate. Oh, there it is.
Is that on
Hexapod game.
P2 or P1?
That's on That's the P2 version, but remember there's a P1 version of this. That's basically the same.
Obviously, I saw it first on the P1.
Yeah, that's the P1 version. It's really the good one. This was just made for funsies. Though this does use the fast fill trick, so it can actually run really high resolutions. If I wanted to connect it to the main monitor that I have, it could actually drive the full 1920 by 1200 panel with unique pixels at 60 frames per second. I say unique, it's solid filled area. But that's quite something, I think.
That'd be over VGA, right? Not HDMI.
Yeah, we are all VGA here.
Yeah.
VGA is, well, I say that VGA is still used in like I bought this monitor brand new, this one over here, and that has a VGA input. So and actually a lot of monitors do have VGA input still. So you can't say that VGA has passed into fantasy.
Yeah, I like the
That would be
VGA better than HDMI, but
HDMI is kind of cursed, and also if you do it on the Propeller, it can only do very limited resolutions.
What is the max resolution and frame rate? Can you do
for
like
HDMI?
Yeah, can you do
depends on your
720p?
clock frequency that you're willing to overclock to.
Okay, say 350 megahertz, or no, 340 is like the edge, right? That's where you start getting into some serious troubles with.
Yes, I haven't actually drilled down to what the maximum is, but I mean, Chip has it running at 960 by 540, which is a widescreen resolution with that's slightly better than standard definition.
How many frames a second?
Well, it has to be 60, otherwise the stupid American TVs don't like it. Even though 50 hertz is supposed to also be supported by the standard.
Oh, there's no 30 frames that's standard?
It's not standard, but it depends. Sometimes it might work. I haven't actually tried it.
So when you get outside the standards, some monitors work and some don't, right?
Yeah, in general, you can actually do in terms of like blank timings, you can pretty much just do everything because the way that it's encoded kind of tells the monitor where the picture is. So it doesn't have the weird issues that you have with like odd VGA timings where like the monitors don't really know what to do with it. With HDMI, the monitor always knows what to do because it knows where the picture starts. There's even 24 hertz modes that exist, but support for them may or may not be as good. But if you do 24 hertz, you can obviously do much higher resolutions, but it's you only get cinema spec frame rates.
Have you ever heard of RGB to HDMI?
What do you mean? Of course, we have. I actually don't have an RGB to HDMI box, I think.
Well, they take a Raspberry Pi Zero and they do level shifting from like an Amiga 500 or an Atari SD, and then they'll get an HDMI output.
That seems, does that actually do it properly? Because there do exist proper analog to HDMI boxes, and they usually have some sort of dedicated hardware thing on FPGA inside them, so they can do it without introducing any delay.
Well,
if you
can't really
used
tell
to like a
delay
Raspberry Pi, it would have to go for like the frame buffer on there, which would delay it in a nasty way.
Well, Jan Beta on YouTube, he's done one, and I've not seen one in person. I haven't got mine installed yet, but it looks pretty good. I don't know what the maximum resolution is. Like, can you do the 1280 by 240 that a 500 plus will do? I don't know, but obviously there's a decent frame rate coming in the pins on the Raspberry, decent bit rate coming in the pins on the Raspberry Pi. And I thought, it sure would be nice to take that bare metal code and do bidirectional stuff so that you can leverage the SD card and USB audio. I'm sorry, USB port, and
yeah, but at that point you can
once,
just
and then the
like
propeller
use
could it what it's good.
Raspberry Pi, right?
What's that?
It's like if you want to, at that point you can just use the Raspberry Pi, right? The Raspberry Pi can just emulate an entire Amiga in itself, so it's kind of unfunny.
Well, the Raspberry Pi, it's well, for one, the development environment for the bare metal stuff. Yeah, I wouldn't want to code too much in it. For one, for two, you can't do analog and twiddle 64 pins and do all sorts of stuff that the P2 can do. Whereas the P2 is just not capable of doing 1080p HDMI. That's why I thought a hat solution with the bare metal.
Yeah, well, again, you can very easily get your hands on VGA monitors if you really want to.
Well, that's true.
Like all the, it seems that all the office monitors still have it, because presumably someone somewhere needs that.
Yeah, I've still got CRTs. I got one left.
I mean, I've got many. We've got the big one back here at the don't know where to point the
Oh, that's
picture, but there's
just TV resolution.
Yeah, that's well, it's technically it could probably do VGA resolution with the tube that's in the driver, but it doesn't. It rather does like TV resolutions but it double scans them, like temporally. Bizarre thing that is. But basically, if you live in Thailand, you get eye cancer because of the 50 hertz refresh. And eventually they managed to fix it by adding like a frame buffer, so that it scans out each frame twice, which adds some nasty delay, but I don't know. That's just the TV I have. I do have a smaller TV. I have some PC monitor. I have a really small TV. I have lots of these. They all fall into fantasy, so I guess so I get them. They just find their way to me by strange means.
Some of these SGI monitors I've had, like the 24-inch CRTs, they're flat. They'll do 2000 something by 1600 on a CRT, but I typically run them at 1920 by 1200. Just beautiful displays, but they're a real pain to move around and ship and make space on your desk and all that stuff.
Yeah, bigger.
And now they're really expensive. Really expensive. A good one's like $3,000.
It just this. We can run another funny. We've seen Hexagon. Can we run this, or does the source explode again? Load. Boot. Start. No. Play. No, actually, we want to go now. Stop. This is what happens when you don't remember your debug the commands for your debugging thing. You forget how you actually started. There we go. Now it's loaded. I have worked on this in a while. I really want to. One, because I want to finish this so I can work on something else. Because if I don't, it will forever haunt me. This is actually for the P1, but I have a P2 version as well that does exactly the same thing, so it's not very impressive. But it's sort of like an action adventure kind of game. It's actually like original. It's not based on some sort of nonsense. It's just actually It just actually exists. Sometimes I parade this around, and then I forget about it for months. I really need to work on this more. But the problem is that if you aren't doing something with a known outcome, it's kind of harder to know, well, what should I do, right? There isn't a blueprint for this. You just kind of have to figure things out. That's how you get things like jumping off the cliff with a funny animation.
I'm hoping the colors look better in person because they're really smudged over the video.
No, the colors look awful in person because this monitor is awful.
Oh.
Maybe we can. No,
well,
it doesn't want to
that's
fix
one of the
itself
things I
today.
like about HDMI. You get well digital pixels.
That doesn't help this monitor. This is the biggest piece of crap you've ever seen. But this, I think I got this when this was like my original monitor from way back in the day. So obviously I cannot throw it away. I'm forever obligated to keep it. But it is a giant piece of shit that I just keep on the desk here because I don't know. It has a VGA input and it's relatively small. But it's a piece of shit. Sadly, I still haven't managed to get the capture going. I did get well, the capture I used to use, which is oh no, giant mess. This is the capture that I used to use. It's a composite video as video capture thing. For some reason, the PC refused to turn on with this in it at some point. I'm not sure if this is broken or my motherboard is broken, but it doesn't work anymore. I don't know.
It's got a RF modulator on it.
A
This thing sucked a lot of. What's that?
A demodulator, if you will. This could actually tune into a TV station if any of those still existed.
Well, I know the RF
sort of the
modulators
primary
suck a lot
purpose
of
of
power.
things. Anyways, I managed to get hold of one of these. Oh, this is a piece of kit for sure. If it was better lighting, maybe. Now this thing is real. This real thing. This is a Data Path Vision RGB E1. These probably cost like 4 figures at some point. I got it for 2 figures off eBay. The problem is there's no real PCI bracket on this. I don't know what the fuck this bizarre thing is, but it's not a PCI bracket. And more importantly, the Linux drivers are like garbage. So I had to fix some of to even get it to boot at all. And I can't keep it in the PC because it would wobble around due to lack of bracket. Now you see this has a DVI port on it. This can capture either DVI signals or it can capture VGA signals with an adapter.
Yeah, I've got some of those that I stripped out of some Linux servers. I used to use them for KVM over the network.
Used it for what?
KVM. They'd go out of the server and then back in, and so that you could control the BIOS screen over the network.
Oh, and you'd buy like something expensive like the data path card for it. That's silly.
I've got like half a dozen of them in a box somewhere. I'm not.
Oh wow, these are actually pretty good.
Maybe I'll send you a picture and see if it's worth shipping to you.
Yeah, if you've got a box full of them, that's good. I've got this one here that doesn't have a proper bracket. When you get this going, it is immaculate. Absolutely immaculate.
Are you talking about digital in or audio, analog in?
Both.
Really?
Yes. The analog is really good, but even the digital, right? If you buy those like cheap USB capture devices, they all put compression on the signal because I don't know they're designed for high resolution, and high resolution you need to compress to put it over the USB bus, right? But and they don't usually let you turn off the compression even if you're doing low res. This never has compression. This will always do full 24-bit RGB.
Because it's got a high bandwidth PCIX 4.
Yeah, this is. Yeah, I think this is 4x. This never does compression. This always does your full RGB. And by that measure, it gives you a perfect one-to-one capture if you're doing digital. I think, anyways. I haven't tested if it's exactly one-to-one. But with the VGA, it's basically as good. You can't tell if it's been captured over analog. It is basically completely free of any sort of noise or blurriness. Somewhere I had a screenshot of this in action, but maybe it's on this USB drive. Let me see if I
Hey,
can.
Ada and Doug. I should get going because there's a few things I got to do today. But I want to put you in charge, Ada. Do you want to do that?
Yeah, I mean, I need to go to bed soon. Anyways, it's.
Before you go, Chip, I gotta. Did you see my chat?
Oh no, let me look. Oh my gosh, there's a lot of stuff.
I was wondering what if you've thought more on a self-hosting P2 system.
Yeah, so that's definitely what I'm working towards. But this last month, I've made no progress on anything P2 because we planted all these apricots 3 years ago, and this year we had a huge crop. So we sold them right in front of our house on the highway, and that went on for like an entire month.
Wow.
And that was like a whole new experience. The county here, I asked like if I needed any permits or anything, and they said no. The law is that if you grow something on your property, you can sell it on your property, and there's no need to do anything. So that's what we did. So as they were coming ripe, I was thinking, well, maybe I can find a store to sell them. And I went around. Everybody's got these corporate policies that make everything impossible or so late that it's not going to matter. So I just ordered some signs from this place. I'll put this in. If you guys ever need to make some quick banners, make sure I get this right. This place was awesome. I made up some signs and they sent them to me. And I put those up on the road, and I got this little like shade canopy, those four-legged things. We put a table out there, and man, for a whole month, people pulled in and they'd come back like every other day. They loved them. And we just sold all these apricots, and now we're out of fruit. So that's over for this year, but it was a cool experience.
I guess that's where you got your tan, huh?
Yeah, I've been outside a lot. I like it. When I sit down in here, it's like, as soon as I stop moving, I want to fall asleep.
Yeah. Yeah, I know how that goes. I need to actually get a physical like farm job outside. I'm about your age. And sorry about this phone ring.
Anyways, what you see here, this is one of those test captures that I did when I was putzing around with the data path. And as you can see, you can zoom into this, and there isn't really any noise or nonsense in here. This is captured from VGA, and it kind of just does it perfectly, which shouldn't be so surprising, but it's actually kind of amazing that it can do that.
Hey, Ada, we get you a ticket. Will you come out here and help with farm work?
Oh no, that's not exactly the sort of thing that's.
You might like it.
You might fall afoul of like labor laws. I sometimes have to help in the garden here too. So that's a lot smaller scale operation, but we always get a lot of tomatoes.
Hey, Chip, this is Martin. Hello.
Hey there.
I agree with him with the garden. I want to just show you something real quick. I've been playing with, actually, a friend of mine. I took a class at my local city college in digital electronics. Had a lot of fun. I wanted to ask you because they taught. I have a DE10 Lite, a D10 Lite that does FPGAs. Is that similar to the device you've used to make all these wonderful things we have?
A D10.
Yeah,
it's like a
I'm sorry.
type of FPGA or something.
Yeah, it does FPGAs. It's from Intel or whatever. It's the lower end one. The school loaned us one. I liked it so much, so I bought one, and I'm having a lot of fun with it and learning what you do. But
D10.
Yeah, D10 Lite.
Not the DE10 Nano?
Yeah, DE10 Lite. Yes, I'm looking at it right here. Let me show
DE10 Lite. Okay, I'm not familiar with that one. I'm familiar with the Nano, which they.
Let's see, FPGA. Oh, here it is. DE4. Oh, a DE10 Lite. Okay.
Yeah, here it is. I got one.
So this has a max FPGA on it. Yeah, this is. This is an Altera. Now it's Intel.
Yeah.
Yeah. So that's. Yeah, you can have a lot of fun with those things. Designing hardware is totally fun.
Yeah, it was just amazing fun. And I'm going to be playing with it again soon. But then she also, the teacher, she used to use your stuff. She conned me into next summer to be a counselor for a robot camp for kids. And she gave me a box of sumo bots, and I cobbled a bunch of parts together. And then we have a ping in the back.
Nice.
I machined that metal to conform to the, as you can see there, it curves with the bracket. That was fun. I have a small machine shop. So I'm having fun with this. And got the grabber up front. And everything you guys have sent me in the what are those
mystery boxes
is going on board this. And I'm just having fun. And going on board that.
Oh, right on.
And I think this is going to get a P2 instead of the P1 that's on here.
Nice.
So, but that's yeah. Have you ever had a contest for anybody making weird stuff?
No.
Might think about that.
Well, I'll tell my brother to watch the last of this video.
Yeah. I'll send him when I get this thing actually running, and I'll send him some pictures. I sent them to Chantal and Christina, and they were laughing at me. My wife says the backside looks like a dog snout.
Oh, wow.
It's all machined and everything. I had some fun with that.
That looks cool.
Yeah. So it'll be running soon. And just had some fun there. But other than that, by the way, you guys taught me a lot today. Thank you.
Yeah.
I just picked up a like rover chair that an old person drove around with a little joystick. It was at an estate sale for $25, and it's got these gear motors and these tires that are like 8-inch tires.
Wow.
And these huge brush motors on it. And I thought, I wonder if Chip's motor drivers will drive those brushed motors.
Yeah. Well, you can do that.
Will it handle the sparks on the brushes and not?
That's a good question. I don't know. Let me think. I don't know. I mean, it's set up to handle the back EMF from, switching those stationary electromagnets. So,
right.
Yeah, the brush noise. I mean, but for what you're doing there, you could just put a capacitor across the motor. And
absorb.
That would probably just take care of it right there.
Yeah, good point. Yeah, I thought
because you're modulating on the controller side, but it's quickly averaging out on the actual motor. You could even put maybe an inductor in series to act, and then a capacitor across the motor, so that it acts as kind of like a pi filter to cut noise down. So you can then modulate at high speed on the control side, and then it turns into DC when it hits the motor.
At 24 amps, how much? I mean, 24 volts. How many amps could your motor driver?
I think we rated that thing for 20, so that'd be 500 watts. It'd be almost a horsepower.
And times 2, right? Because don't you have 3 channels on that one?
There's 4 channels, so you could run a brushless motor on 3 of them, or you could run 2 brushed motors on 2 each of them.
So on one of them, could I run 2 brush motors?
Yeah. Yeah, they're totally independent channels. It's all how you program it.
Yeah, I've thought about turning it into an automated wheelbarrow.
Oh, yeah.
Because that chair, the chair frame and motors and stuff, that'll handle 250 pounds.
Ooh, that'd be cool.
Anyways,
Oh,
I,
yeah.
I think I'm tired and I need to go, but the problem is that have the power.
Oh, send it back to me.
Let's see where no, I don't want workplace. No.
Just right click on my picture.
Oh. Oh. Make host. Yes. Yes.
Are you okay, Ada?
No, I am not.
Okay, well, Ada, I'm a retired nurse. I can help you out. We got good drugs over here.
Oh man, no, I was just mimicking the Tempest 2000 sound effects. Sorry, I am now Super Zapper recharge. No, that's not how I say it. Super Zapper recharge. Yeah, that's more like it. And like television is the retina of the mind's eye. Dot. Dot. I didn't actually show you this audio from that earlier, so you have no context to this. Anyways, me and my soft friend here will have to beg or leave here.
All right. Well, thanks for coming today, Ada.
Yeah. And I'll leave.
It was cool to see your Tempest game. That was pretty neat.
Yeah, I really wanted to get the everything done for today, so I can say, oh, it's finished. But I don't know. The past month has been turbulent.
It looks pretty complete to me.
Yeah, it's mostly that one bug with the line clipping, and there's a missing feature regarding the audio where it should fade between things, instead it just cuts. And also there's some of the music tracks that don't play correctly. Because as mentioned, mod is a stupid format. Anyways, I have a
Oh, Ada's gone. All right.
Do you really have to go, or can I bug you about the P2?
No, we can talk a little more. I was just going to try to before it's 5. I got to try to order a part for the tractor.
Oh, yeah. Sorry.
That's all.
Okay. So yeah. I've been thinking about hooking a P2 up to different boards, and when it came right down to it, I think a Raspberry Pi would be killer to have like a Pi hat where the P2 would run by itself with its own USB and its own video. I would suggest VGA out of the P2. But
oh yeah,
when you hook it up to the Pi as a hat, all of a sudden you could boot directly off the Pi. You could use that program. I forget it. I haven't done P2 work in a long time too, but I've just been thinking about the possibilities because P2 can't really do full HDMI or full 1080p HDMI.
Right. It can signal in analog, but not.
Right. It can do it in VGA. It can do 1920 by 1200 in VGA even.
Right. Yeah,
But,
and you could get a $17 converter off of but it's kind of an ugly arrangement, you know. I've been working on my little, standalone computer idea here, and this is analog, but this down here is the HDMI, so that's what I'm running because I want to make it easy for the customer, even though this would afford better resolution and whatnot. With alpha blending, lower resolutions that I can do on HDMI look really good. So it's kind of like maybe we don't need all that high resolution because really the lower res you have the faster you can update the screen anyway, you know?
Yeah, that's
I can make pixels disappear. I mean, the blending works so well that you can't really see the edges of pixels, and you just don't have as sharp of an image, but you can't see pixels.
how many colors are you running?
Well, 24-bit.
Oh, okay. So, and what resolution are you outputting?
I think it's like, let me look. I have it open here. 960 by 540.
Okay, that sounds like what Ada was referring to.
It's like quarter HD is what it is.
Oh yeah, okay, that makes sense.
Yeah, see, I can take my little camera here and I can point it at the screen. So this is like a super low res demo of just how the anti-aliasing works.
Right.
And then it's going to quit this in a sec. Yeah, and you can't tell it's anti-aliased on this camera, but those lines are super good. And then we have, nice text I can put that's.
And you're running vertical, so you're running
Portrait
540 by 540 by
960.
960, yeah.
Yeah.
Okay. So have you talked to your customer base and what they really want? Because from my point of view, it looks like I don't think you really can compete educationally long term with the Raspberry Pi and all these cheap things coming out of China.
Oh yeah, no, it's I agree. I mean, in a sense, it's impossible. But I think if you were to able to like introduce this to someone and have them use it for a little bit, they would have an experience where it's super responsive and they instantly start to develop like a sense that, oh, this thing's going to do whatever I program it to do, and it's going to do it quickly. And I don't know that anything else gives you that feeling, because you're dealing with all kinds of funny things like garbage collection and who knows what not.
Yeah,
So,
who knows? That's the big part. We don't know what the heck Linux is doing. We don't know what Windows is doing. And with the P2, you're on the hardware, you tell it exactly what it does, and it does it every single time cycle accurate.
right.
But
yeah,
what I would like to see is you guys leverage the power of the Pi infrastructure and just, what do you call it? Economies of scale, so
yeah,
that you can have the best of both worlds in a hat.
yeah.
So with I was talking about there's this project on the Amiga and on the Atari ST, and there's even an external one. On the Amiga, it sits right on top of the Denise chip. The Amiga has 12 bits of graphics, and so there's a bare metal program on a Raspberry Pi Zero, which aren't available anymore, but you can get the Zero W for like $10. And it samples pins on its 26 or 40 pin GPIO header and turns them into pixels on the HDMI. And I don't know what the maximum resolution is, but it's doing 12 pixels, and it looks better than the original. Looks better in the CRT. I got to get mine installed, and I got to dig into the hardware. The board, the little board that it's called the RGB to HDMI. It's like a $20 board fully built, and then you unplug your Denise chip, plug this board in, so it gets access to all the digital inputs to the Denise, and then you plug the Denise on top, and then the Pi header, you plug in a Pi Zero, and it'll output rock steady HDMI. And I'm not sure what resolutions, but probably all the way up to 1080p. It probably does pixel doubling. I know it does pixel doubling. I'm not sure it'll do quadruple pixels or whatever. But part of what that board does is level shift because the Amiga is a 5-volt system.
Oh
So
yeah.
you can cut all that out. And I don't think there's anything else on it. I think that little board just does level shifting into the Pi, and then the bare metal program on the Pi, which is like less than a megabyte, boots off of an SD card, and it just runs. It never even writes to the SD card, so runs reliable. But for like a P2 dev system to get it in the hands of people, you could start out with just a simple interface like that, so that you can do HDMI without expensive hardware and a whole bunch of things to plug into the P2. And you can get your real-time video out, and you can do all your real-time stuff and do exactly what you want, like you're talking about on the P2, leveraging the cheap hardware of the Raspberry Pi.
So what role would the Raspberry Pi play? Would it be like the user interface?
It would be your HDMI out in one way, and you can do what you want on the P2. You can put your keyboard and mouse on the P2, or you could add that functionality to your Pi if you want via
Right.
USB. But I think the key for you guys to get back, you used to have more exposure, I think, in the educational world than you do now. I'm not really in that world, but that's
Yeah, there's a lot of contenders, and what happens is something becomes somewhat of a standard, and then the Chinese crank it out for a few dollars, and it goes on like that.
Well, they can't crank out P2 chips.
No.
And Raspberry Pi is already cranked out so cheap they can't really compete, and because nobody wants a cheap Chinese quality thing when they can pay just 10% more and get a quality thing out of England or wherever they come from.
Right.
So you really can't compete with that because you don't have the economy of scale. But what you do have is a chip that people would love to program because it does exactly what you tell it to do. And so I would guess the first thing to do is get your HDMI out, coming out of the RGB to HDMI through that Raspberry Pi Zero, and then
can the Raspberry Pi do that job?
Yeah, it does it for the Amiga.
Oh, so you're saying but isn't it emulating the Amiga, or are you giving it
No,
like
it's
signals?
No, it's taking digital signals that the Denise chip is putting out.
Okay.
And Denise is part of the Amiga chipset
Right.
that draws the screen. It's like the display generator on an SGI, but so the RGB to HDMI board sits in between the Denise and its socket, and then so that the Raspberry Pi gets access to the 12 bits of digital video signaling, right? Your 4 bits of each color, and it puts out HDMI rock steady.
So I wonder, how is this? Something is feeding many parallel bits to the Raspberry Pi, right? And then it's converting that data into an HDMI signal.
Right. And that's a program on GitHub.
Okay. And you said it's 12 bits, so it's like 4 bits for RG and B. Is that what it works?
Yeah.
So they're using 12 IO pins.
Yeah, and the Raspberry Pi's got more, and I'm thinking to start using that and getting that going, and then start adding features like how many bits can I go for bandwidth, right?
I see. Yeah.
Can I add a serve program so that instead of tying up anything for PSRAM, can I do real-time serving of 512 megabytes of RAM off the Raspberry Pi back to the P2 instead of PSRAM?
Right.
And then can I use the Pi as a file server, and then can I use the USB inputs? And there's a limit that you're going to run into where you can't do real time anymore, because as far as I know, this program is only, this bare metal program is only single core. So even if you have a 02W is a small 4-core board that's still only $15, but you'd only get 1 core of it.
Okay.
But the cool thing is you could literally just put a different card in your Raspberry Pi, and now you've got your development environment for the P2.
Mm-hmm.
Download it into the P2, and then when you could like maybe dual boot it so that you boot after you load the P2 or load the flash on the P2, the SPI flash, then you reboot the Pi on the bare metal program, and then it's now the P2 is in complete control.
I see.
And it's, we're talking dirt cheap.
Oh yeah.
An SD card, a $15 Raspberry Pi, and whatever the board for the P2 is.
Right.
So I think that would be low hanging fruit if you could get it working, and just working with the Raspberry Pi as like a hat gets so much attention. And the Raspberry Pi just does not do real time. I mean, it'll do real time bare metal, but it could be beyond that, where your P2 is running like Ada does her games, right?
Right.
She's got a development computer, and then she loads the P2 over serial.
Right.
It's got a serial port built in. You don't need your FTDI chip.
Oh yeah, yeah. I see what you're saying. Yeah. Yeah, it could actually suffice for a lot of interfacing purposes.
Yeah.
Plus it has fast USB, which is good for some things too.
Right, USB 2. And
I mean, doesn't USB 2 and maybe 3 actually have like a monitor protocol where you could actually drive a display? Like it has a display protocol.
Oh, I don't know about the protocols, but there are display adapters for USB 2. They've been around for a very long time. Not that I would want to use one. I personally would rather, if I was programming the P2, I think people would, the great thing about the P2 is the real-time aspect of it, right? I don't know if how many people in the forums actually use interrupts?
I don't know. They're good for situations where you just need to break and do something and have a short service routine.
Right.
It's useful for that, but not in the way like a operating system would use them.
Well, like the P2's got like its own operating system. I mean, it's got the low levels of an operating system.
Yeah.
But it's fully controllable, and it's fully real time.
Mm-hmm.
And it's more of a hands-on experience. You could, I think if you built like a P2 demo board into a Raspberry Pi hat, and even if you just got the P2 right now, you plug your USB into an FTDI and you boot your P2, right?
Right.
Even if you just eliminated that with direct serial coming out of the Raspberry Pi into a hat, now you got a board you could sell to educators that are already doing Raspberry Pi stuff, but they can't do real time.
Yeah.
They can't do the analog.
I could see that, Doug. It would be nice to sell lots of P2s like that.
Yeah. And I think that would leverage something you can't compete with.
Right.
And also get into that market, which is huge.
If I can interrupt for a quick second, Chip, that goes back to it'd be really nice to have a manual like you had with the P1.
Oh, I know. Yes, I
Okay.
agree.
Who
And
wrote
because
that thing again?
What?
Who wrote that manual? Because I love that manual.
Jeff Martin.
Yes.
He's still around, isn't he?
Yeah, yeah.
And he's working on it, right?
Yes, but he's tasked with a lot of like IT. We need to simplify our IT situation because our old IT guy retired, and we want to simplify things after he's gone. So Jeff's tied up, unfortunately, with a lot of dumb stuff like that.
Because for me, the pins are really cool, but I'm having a hard time wrapping my head around the pins, and it's
Like the smart pins.
Yeah, the smart pins.
Yeah.
I mean, it's really cool stuff, but man, we need a manual to bring us dummies like me up a little faster. And if you go that route to those teachers and stuff, you're gonna have to have a manual.
Yeah, no, I know. I totally agree.
If you handled the P2 with the same kind of depth you handled the P1, though, that manual would be like 2,000 pages.
You wouldn't have to go that deep. Just some basic examples.
What we need is examples. A little elaboration and some examples. Because I put everything, every detail I put into that document. So when I can't, because there's a lot of stuff I can't remember, I have to like look it up. So I always go back to that documentation. Everything is in there. But I have the context of like as I read those words, I remember what the intention was. So I get more out of it than someone else would. But what we need is a lot of examples to demonstrate the different modes and how they work.
Well, if you could take like the simple examples you did in that first manual, right down to the one with the capacitor as it drains down. I can't remember which one that was. Those simple examples done just with the code, and then later on with a pin version, if that's applicable, in there, and you can see the difference between the two. That would be a hell of a jump start.
Yeah.
Martin, when you use the P1 manual, do you use it online or do you use the paper?
Oh, I have a brother, watch this.
My son sogged my P1 manual. He was programming the P1, and I don't know if he left it in the rain or whatever, but I had to buy another one.
Oh no.
I can send you the file. I have multiple copies. I just had this thing rebound. I've had this for years. Yes, and I always refer to it.
Did you print that out yourself, or
I had it printed out years ago? But yeah, it's too many pages for me to print. But yeah, I mean, it's the print shop cost me $5 to have them put this back on here, and I've had this for years. Plus, I have several copies of the file. I'll give you my email address. I'll send you a copy.
I've got.
That's interesting. I like stuff like that, but I've forgotten about stuff like that because I don't see it anymore.
And I got notes all over this thing.
Yes.
I've read this like a novel multiple times. So it's just beautiful. I got notes all over the place.
Wow.
What boards do you use with that?
I have a WX board in front of me. I've got some quick starts, and then I have my own board, which I designed a long time ago, which I made basically on one of your old boards. I had to learn how to do it, and I got a P1 in here, and this works. This goes on my shelf next to the original P2 that you guys sold me. But yeah.
Wait, who made that board?
This board in my hand?
Yeah.
I did.
Oh, nice. Okay, because it looked like something. Do you remember a long time ago there was a guy on the forum named Sapieha?
I think so, yes.
I think he passed away, but he was like in Sweden, but he was from Eastern Europe somewhere. But he built something very similar to that.
Yeah, so you had a board that had the surface mount version of it, and it had all these little guys on there. So I designed this, learning how to do it. The only thing that I had to where is that guy? stereo one over here, is the only thing that as surface mount soldered. I had to learn how to do it. And I actually etched a board to go play with that, which I have here someplace in my years ago, trying to learn how to do this. And so I learned how to do it. I made several versions. So I got this one, and I still have to rearrange the furniture on it. And I have to learn, but because these guys up here, and there's not enough room for them. But and I sent one to Josh. Remember Josh? Remember Josh?
Yes.
Yes, I sent one to him, and I put it together and everything, and he lost it, but I have another one put together for him. But yeah, I learned how to do it, and this was a whole lot of fun, part of the learning experience, because once I got into, I took an electronics class, and then they talked about the basic stamp, and then I called you guys up, and since I had programmed on the old IBM 1130s and 360, 370 systems way back when, okay, they got me into the P1, and I went from there.
Nice.
And that's how you've got you're stuck with me.
Yeah.
So I'm going to redraw one of these and do it again, because I got a bunch of these chips. And then I have 4 of the P2 chips, which I'm going to do this, probably the same board. I just got to find somebody to mount it for me. And everything else will be through hole except for the P2.
So that's cool.
And I'm having fun. I mean, I'm 68 years old and retired and having fun. And that's
cool.
what you did to me.
Yeah, that's good.
So, and then I'm taking my next class is AM FM radio from scratch, no chips. The teacher, she's like 35 years old, got a top secret clearance, and she's got her master's in electronic engineering, and in her and then her compadre's got the same, and now she has me working on something else.
Notice, Chip, he's got VGA and PS2 on there.
Yeah.
Yes, sir.
Those are still my favorite.
Yeah.
I'd rather have a USB mouse, because the better mouses are USB.
And then she loaned me one of these to make it work, gave me a kit to build another one for me because they lost the controller. I liked it so much I bought one. And I'm going to probably put first P1 on it instead of its brain, and then P2 when I learn how to use it with a manual. But this is kind of cool.
Yeah, is that like 12 servos on that thing?
Oh, let's see now. I got here. I'll show you the back. Well, here's the front. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, there's 12 servos on this guy.
Wow, that's pretty cool.
These are $1,600.
Oh,
Man.
Okay,
I mean,
that's a lot of cool.
Yeah, it's a lot of them. Mm-hmm. So I bought
the
basic kit. I got to get 2 more parts to do the rest of the humanoid one. But it's like, yeah, it's going to be fun. But it's like, yeah, and I really want to put a propeller on this guy. Since I'm building mine, I can hack it and do whatever I want to do to it. But I think it'd be really cool to put some other neat stuff up here and all kinds of toys that you guys have given me.
Interesting.
Yeah, hey, that's you, like you said, equip your genius. You've made me into a genius.
It's fun tinkering with things that just work, rather than fighting with operating systems.
I kind of think, I just cannot imagine that there is not some completely unquenched pent up need for something that just works, because nobody knows what that would even be like now. It's kind of a hypothetical that's hard to imagine, but I just want to make something that works really well, and it always works, and you can rely on it, because when you have confidence, you can work 10 times faster. If you don't know what's going to happen, or you're getting inconsistent results, you're very hesitant and you can't progress very quickly.
Well, that's one of the reasons us Gen Xers have gotten into retro computing. I mean, it was huge during COVID, and most of the people that I saw doing retro computing, like the videos that I'd watch, getting back into Commodore 64s and Amigas and Atari STs, and in Europe they were into Amstrads and that ZX Spectrums and stuff.
Oh, yeah.
You turn those things on and they're ready to roll, and it's like the same experience every time. Not like Windows, you power up and you get this little blue screen and says wait for an inordinate amount of time until we tell you you can use your
Well,
computer.
then there's all these inexplicable delays and weirdness, and then they keep changing everything because it's nowadays a managed experience. They're changing things on you all the time. Like even my cell phone, it's like it doesn't update, and then the app, like the text messaging app, has changed, and buttons have moved, and it's like, oh, it drives me crazy.
Well, Linux is better for that, especially if you don't do the updates. Like on this laptop, I'm running right now. I since I don't trust Zoom because they did a rootkit years ago, I booted off a CD and installed onto the live CD, so it's not even talking to my installed operating system. But when I boot the CD, I get the same experience every single time.
That's good.
Raspberry Pi can do that too because they've got images going all the way back to 2012.
Yeah.
Those older images won't run on the newer hardware, but it's definitely a happy medium between really, really reliable and
powerful, useful.
Microsoft and Apple's change your world for change's sake kind of nonsense.
Yeah, for change's sake, that's right.
I think us Gen Xers have enough wisdom to see that kind of garbage going on that we don't like it. It just interferes with what we know how to do.
Well, yeah, it's to me, it just kind of turns me off on the whole genre of everything,
Have you tried the Raspberry Pi for a development environment?
No. Oh, you mean, I don't know if like Maca's tools will run on it. I remember someone was bothering to make their tools work on it. I can't remember who that was.
Maca was, but the mainline one, what I forget what it's at. I haven't used it.
FlexSpin or
Flex GUI, yeah. FlexSpin, Flex GUI. It's still revving, and because you're still revving, but Linux doesn't have to rev, especially on the Raspberry Pi. You can just burn an image off of Raspberry Pi and put it in a Pi 4 and roll with it. It just works, and it works the same time every time. And if it doesn't, well, it just re-image the thing. You're back to where you were in about 10 minutes.
Yeah.
So Windows and Apple, I just rejected them years ago, and I think I've saved a lot of time, even though Linux is harder to use, especially with new hardware. Mm-hmm. And when you upgrade your hardware, there's always Linux issues.
Right.
I'm still I can still run what I want to run. Like the laptop I'm using right now, I've got like half a dozen laptops, and this one is an old Alienware with a second generation i7. It runs Ubuntu 16 just great.
Wow.
And I don't upgrade it. There's no upgrades for it available anymore. I don't use it for crypto or anything where I need high security because those things haven't been patched. But at the same time, it does what I want it to do without getting me interrupted.
Right.
So I personally would recommend getting a Raspberry Pi 4 or 5 or 400 and just try FlexSpin on that, because you won't run into the same kind of issues you'll run in with Windows. I mean, you won't get the speed performance either, but you look at the board and you only got like 4 chips on a Raspberry Pi.
Yeah.
Versus hundreds on a typical PC.
Oh yeah. Yeah. I'll look into that. I will think about that. I just don't have I'm not up to date enough on things to know how to think about a lot of stuff.
I wish I lived in California. I'd come and visit and bend you ear more often and help you with some